to unlock. For those who want more...
Or, you know, an ad could just play. That's good. You know, that's cool too. That's what I get for signing out of YouTube. Jeez. Alright, just stop. Let's just start. Screw it. I want more. I want more from my thing. Alright. Alrighty. Let me fire up YouTube here. Give me 1 second. Okay, what's going on YouTube? What's going on Twitch? Welcome to part 7 of our post-Apollo Saturn launch vehicle build in KSP. How you doing? Oh, man, I knew I forgot something. I gotta get the fan in here, dude. I gotta get the fans. We gotta get the fan in here. Cause it's still a little hot in here. I'll be right back. I'm just gonna bring up the fan. Okay, I'm here. I'm back. Plugging the fan in, turning the fan on, making sure it doesn't blow on the dang microphone. Ah, much better. Out of sync, don't do that. Don't do that, man. Dude, that computer is pissing me off. I'm about to throw it out the window. Can we watch the Grok 4 unveil for Space News? Gork? Why do you want to talk to Gork? Alright. Should have a shop camera on one of the monitors, mission control, like the... Oh, a shop camera? All right. Okay, sure. Let's see something. Let's see something here. There's no way that camera's updated. Hold on. I have the lights off in the shop to keep it cool. I see the overlap. Okay, we'll fix that. Hang on. It can't be updated. The lights are off in the shop. What's it? It's strange. Does this work? I restarted the computer out there and I don't have OBS on. So that was the last picture that it saw when I shut it off before. You know what? We'll figure out this problem later. We'll do this. We'll figure out that later. I'd have to go turn the computer OBS on. But yeah, it can be done. I have plenty of monitor space. Dude, we could even put the garage on one of the big monitors if you really wanted to. We'll do it live. Frig it. Anyway, Kerbal time. You said duty. Duty. All right, so this is what we're working on here. The post-Saturn Class 1 baseline vehicle. This thing. We're trying to make that in KSP. Let me get the joystick hooked up before we start the game. Okay. How's it going? Picking up. Everything's fine. A desync on the monitor is going to bother me for the rest of the day, but that's okay. It's okay. All right, so zip that down. Turn on Kerbal. Let's get the music going. Turn the music down. Halligar, just in time. Happened to be home on paternity leave. I can watch KSP streams finally. All right. See that they may have found possible life on planet K2-18b. No, but that's cool. Nah, let's go over here. Hey, Creepshow, how much of a baseline knowledge do you need to get into Kerbal? I was thinking of giving it a shot. None. Just play. Play and figure it out, dude. I'm ready for my herbal spice program. Oh. All right. Oh, it's Kerbal. I gotta go to that side. Oh, yeah. Here we go. All right, let's do this. I'll turn the music down just a smidge. There we go. All right. So, where we last left off, we were having some issues with the vehicle's back snapping in half. Let's see if that test still is a thing. Because what we were really running into was some problems with the simulation was doing different things every time, and I think that might be because of the engine plate, but this attachment point right here was snapping. That is where the back of the vehicle is attached to. So I have a forward fairing, engine plate, aft fairing, aft skirt fairing, in that order, right? And it was snapping between the engine plate and the aft fairing, which is... the aft fairing is the main body of this thing, which is very weird. That's a really peculiar thing to happen, but... Alright, so let's just see if we can replicate that problem. Right? Add a probe core. Add some batteries. Solar panels and stuff. Eight-X symmetry hold down clamps. Top like that. Make sure they're outside. There we go. Put those in heaviest part symmetry. Move the launch clamp staging group up here. Save. And switch it over to the VAB. What is a combo? Why is there a horse on my screen? Don't mind me just horsing around. Alright, so... let me turn this down. Whenever I snap a bunch of engines on all at once, it gets loud. Headphone users. Headphone users. Headphone users. Ready? Structural failure on the linkage between yeah, same spot. Cracked in half. That's no good. Good, our first explosion of the day. So we gotta figure out why that's happening. That's good. So we can replicate the failure mode, which is good. Now, gotta try to figure out why that's happening. Yeah, no problem, diabetic. All right, let's go back into the Mastercraft file. So we're having a structural failure between this piece and that piece. And it really doesn't matter how it's attached. It could be attached to the big attachment point, it could be attached to the small one, but it doesn't really work. The idea that popped in my head all of a sudden, what if you took the rocket and just got good? Very helpful. I don't think there's SVI on any parts. No, doesn't seem so. Oh, we're doing KSP now. This schedule is so confusing. I did the car in the morning, Kerbal during its regular time, Space News is going to be during its regular time, and then I want to play Summer Car for after hours. What's confusing, Cheeseburger? Where are you getting lost? It's a longer stream today. I'm trying to give you more content. That's usually what you got to do when you come back from vacation. You gotta give more content. Let's go in here. Now, I hate the VAB editor, but this will afford us to do a little bit more rapid prototyping. Can't run that strut, so here's what we'll do. Down in my thrust structure down here, we'll run a strut from the bottom of the fairing to the fuel tanks. And that's another connection between the bottom of the vehicle and so this is the part right here technically that keeps snapping. This part is attached and moved into position down there, but it's attached to that part directly. So let's see what reinforcing that does, if at all. Let's just go from there. I've not yet figured out what the goal of this vehicle is. Sorry if you already told chat, but I was away for the start of the stream. The goals? So my stakeholder expectations are to be able to deliver 260 tons to low carbon orbit. That's it. I'll figure out what I want to do with this thing later. This is the first time I've played KSP in a long time, Livin'. And this build is really just kind of... I haven't played KSP 1 in probably over a year. And I know that those are words I never thought I'd say. I haven't played it in a long time, so this is kind of just me reintroducing myself into doing cool stuff in KSP. This rocket doesn't necessarily have a goal, but if we get it working, I'm sure we could figure out something to do with it. All right, ready? Immediate explosion. Structural failure between and the entrance. Want your graph file? No. No. I don't want your craft file. Your craft file is edited. It has an edited fairing in it. I don't want that. I'm not sure, Block. I haven't proved it yet. Bye, 95. I'm thinking, I think a structural intermediary would probably be a good idea. It might be that just the amount of force that we're putting on the bottom of this thing and the fact that the engine plate and the fairing are so dang far apart from each other, it could be causing an issue. I mean, the engine plate's like right there. And that is connected to a part that's right there. That's a long way away, dude. Especially for the amount of force that we're putting on this thing. Huh. Yeah, no, let's look at revision 4. So revision 4 had all this like really nice reinforcement. And that had an intermediate fairing. Okay, you know what I'm going to do? Let's go to a revision 4 stage test and remove all the struts. We learned from revision 4 to revision 5 that removing the struts actually makes it stronger. It's most likely because we're making the tank structure too rigid for the shock load. That would be my guess. So let's just go right up the list. The reason why I want to revisit revision 4 is because the revision 4 booster still has a second fairing. So we originally made the skin of this vehicle out of 2 cylindric fairings that were kind of bunched up against each other. And in revision 4, I made it a single fairing. It's one big fairing that's built at the back. That fairing is the outer shell of this vehicle. And I left the other fairing in there because it was easier to do that. It was easier to just leave it. And what we learned from revision 5 basically is that we don't really need these. They'll stay basically auto-strutted in position. Like even this thrust structure down here, we don't need any of that. And since this is a test file, I have no problem getting rid of all this. Fuel tanks are only strutted onto the forward fairing right there. That's it. It's just an X-brace strut. Nice, Trey. I hope he does the space thing and not the Congress thing. I would like to see a continuation of the Polaris program. Just go back to what you were doing, dude. Don't get into politics. But, whatever. Alright, so this is a modified revision 4 here, right? With the intermediate fairing to try and strengthen up that attachment plate. Ready? Same failure. The auto strut's resetting when you disengage the launch clamps. Yeah, we could try it without them on, but I think it'll fall off its mount. Gotten it to work before, note. Well, we dropped it that time. Let's see. Let's get rid of the clamps entirely and see what it does. Yeah, no, it seems like whatever's going on, it's a consistent problem. I find that Kerbal with its memory leak doesn't really screw with the simulation. It's because it's the garbage collection systems that have the memory leak, dude. So the simulation is always the same, no matter if Kerbal's using 17 gigs or 7 gigs of memory. Simulation stays pretty damn consistent. It's same error, no matter what. It just happens slower. The simulation just slows down a little bit, that's all. But it's the same error. Okay. Well, clearly having the engine plate in line like that, not great. Oh, one of my lights is flickering. I'm thinking, dudes. Give me one moment. Okay. There's an old school way that I used to make this. That I used to make these things. I made super heavy craft like this before with this much thrust. It's definitely a thing. I haven't made them with the fairings surrounding them, but I think I got an idea. So do you know what specific sections are breaking? Yeah, I know exactly what section. This is breaking. The connection between this part and that part is breaking when we fire the engines. Also, these are off by 1 tick. Or off by, wow, they were 20 mil out of, or 20 centimeters out of whack. Did you expect this project to test your Kerbal knowledge? I wouldn't have done it if I didn't. Wouldn't have done it if I didn't want to. I mean, we're doing anything that's not just stacking tanks on top of each other in Kerbal. It's always going to warrant testing of your skills. Let me think. I gotta think for a second, dude. Sorry, I'm gonna dead air the stream for a moment. Yeah. Okay, there's a couple of things that I want to change. We have 19 engines here, and 13 of them are pushing up on that fairing. And that's most likely what's stressing out that point. We have 13 engines. The ones that are highlighted right there are the ones that are pushing. Now, that's pushing on the center section. And that's obviously overstressing the connection, the part connection between that and the tanks, right? I'm pretty sure that's my running hypothesis for what's going on here. So for this R5 booster, what I'm going to do is I'm going to take the whole outer ring of engines and attach those to the fuel tanks instead. Right now, I only have 6 of them attached to the fuel tanks. The other 13 are attached basically to that fairing and gizmoed out into position. We're going to change that. So let's go here, get rid of that, get rid of that, get rid of that, because all those struts are in 6 times symmetry. Take the engine, and let's go in here like this, and we will attach it right there. Oh, has to be in 6 times symmetry. We're going to attach it there. And then I'm going to turn this so it matches the vector controls on all the other ones. Now, let me just make sure that that's all lined up correctly. I'm just going to make sure I gizmoed it into the right spot. So I'm going to take same engine. Yep, it's in the right spot. Cool. Those are just fitment engines. All right, so I just readjusted those to be attached to the outer tanks. I'm thinking we're just it might be something as simple as just shock loading our thrust structure, guys. It could be that simple. And if it is, well, we're about to find out. Because the Kerbal attachment joints can only take so much before they break. They have a maximum load, right? Kerbal isn't a soft body simulator. The only thing that's deformable and breakable is the joint. Parts, if the part exceeds and if it registers an impact, right, and it exceeds impact tolerance, the part doesn't crush, it just explodes because KSP. So it's not like Beam where things are going to crush themselves.
Discovery, go at throttle up.
Hey, Jack. 16 months. Prime needs auto renew. Yeah. I mean, dude, if you tier 1 sub, it'll renew for you. Prime doesn't renew. That's what they do. They do that on purpose. Yeah, dolphins. What do you think I was talking about, Ben? Alright, so now we just need one more strut. It goes from there to there. Now this is the other ring of 6 on the outside. I'm just going to make the struts match so we have some uniformity. There we go. That's nice and symmetrical. Cool. All right, so that was a really quick change. What I did was I made it so only the center 7 engines are pushing up on that fairing plate. All the other engines are pushing up on the fuel tanks. I probably should have done that from the start, but hey, Astrophysics, what's up, man? Hang on. Drop door or something. Remember how the old launch escapes towers could take unfathomable impacts? You could use them as landing legs, dropping them out of orbit without any chutes. It would just safely buoying on the ground. Yeah, I never utilized that, but are you gonna build a launch pad for this thing? Rem, I would love to. My real question is how? How is that? How are we doing that? How is that happening? That would be cool, but yeah, how is? I don't know, man. Maybe we'll get it working, and then I'll get back to you. Chris, what are you saying? If you had a designer rocket from the past, what type of rocket would you do? Not one of the rockets you're doing right now, but one of them make it better. I'm not understanding what that question means, Chris. Are you talking about rockets that I've made in Kerbal? Like, what design would I upgrade from the past? I don't know. I've built a lot of different rockets, dude, over the years. A lot of different carrier vehicles. The two most notorious vehicle, actually three most notorious vehicles that I've built that we use the most in all of my saves is, first one is the space shuttle. I built a really high fidelity space shuttle last year, like early last year, like probably about almost 2 years ago. Was that 2 years ago? CTS 5 was 2023. Anyway, I built a really high fidelity shuttle, and I don't think I could make it any better. It flies exactly like the real one. I put the parts. I built that shuttle in a way that makes Kerbal aerodynamics act like real aerodynamics, and that was really hard to do, but we did it. It flies exactly like the real one. If you don't get it back to the runway, it'll stall and it'll crash. Woo, you had me out working on your truck? Nice, 16. That's probably the most notorious vehicle, but I've already remade that. Another vehicle that we used a ton was Condor 9, which was a Falcon 9 ripoff, and I built its entire launch complex for it. I would drag the first stages back to the launch pad, put them upright on a launch pad that I made out of rocket parts, and launch it again. That was fun. That was a good time. The third most notorious rocket that I used a lot was Neptune. Neptune was a big rocket like Prometheus, but it was like Prometheus but without the fairing. And I think it had 33 shuttle engines in the first stage. So I'm no stranger to doing stuff like this. We've built big rockets before. Another rocket that I really like that we should probably revisit at some point was Freedom. My Freedom rocket. The Freedom rocket, it was fully reusable. Well, not fully reusable. First stage was reusable. And I had I built out an entire launch complex for it. You could roll the thing back to the launch tower, pick it up, stack it, put another upper stage on it, stack that, put a payload fairing on it, stack that, and send it. Freedom was not a big rocket, though. It was a small one. It was a small one. It maybe moved 9 tons to low Kerbin orbit. Like maybe 9, maybe. Maybe more if you didn't reuse the first stage. Yeah. I have all of them, Jack, yeah. Yeah, they're around. Either on my old computer or on this computer right here. I have them. I used to back up everything like triple redundant. I haven't done that in a long time. I haven't done that probably since like 2019. But everything is backed up. I never delete anything. What changes have I done so far today? I just put the outer ring of engines attached to the fuel tanks, and then the inner ring of engines is attached to the fairing plate. My running theory is that we kept snapping the back of this rocket because I had 13 engines pushing up on this thing, pushing up on basically the connection point between the back of the rocket and the front of the rocket. And I just think the attachment joint just can't take it. So I put some of the thrust out on the fuel tanks instead. And that might be the thing that fixes it. We're ready to this thing should be ready to go soon. Like, we should be ready to go. Yeah, anyway, more questions in the YouTube chat. What's up? Do you think Starship will generate power on its journey to Mars? Yeah, absolutely. You're going to need some type of solar panel. Yeah, you're going to need some type of solar panel. Just even with Starship, with all of its power, it's still going to, the transfer window, even taking into account the transfer window to Mars and its most opportune time, i.e. costing the least amount of delta V, you have about a 3-month coasting period. So it's going to take 3 months to get from here to there. I don't think we have a system that's currently operable with spacecraft nowadays that could do something like that other than solar panels. The other option would be some type of nuclear power source. That's on the horizon. That might be a thing soon. I would just go with solar panels for now, because solar panels work right now. Nuclear power does work. We have generated power in space with nuclear reactors. NASA does that all the time with their deep space probes like Voyager 1 and 2. They have a little nuclear, basically have it's called a radioisothermic electric generator. It's just a can that has nuclear fuel inside of it, right? And it's just sitting there. And when nuclear fuel just sits there, it decays and it generates heat. And what an RTG does is take that decay heat, that heat energy, and convert it to electrical energy. If you use the right material that has an extremely long half-life, you can generate power for decades. Which is why Voyager 1 and 2 have been out there since 1977, and I think 77 and 78, and they're still on. We've never refueled them. Pretty cool, huh? Radioisotopic, not isothermic. Yeah, there you go. I always get that one. I always get it wrong, but I know what it does. Have you seen the trailer for Project Hail Mary? It looks like a good movie. Should be pretty neat. Did you hear the news from NASA? No, and I probably don't want to, Creation, so don't tell me. And I'm absolutely serious about it. If it's I think it's the news that, yeah, no, I don't, nope. Space news. Not doing that right now. Aren't solar panels unviable for deep space because they are a lot less effective? It's fine for Mars transits, dude. Yeah, it's fine for Mars transits. Yeah. It'll be alright. I was wondering how you would build a launch tower in game. Home planet, building GSE for something like this that would be a little involved. It can be done. It can be done, but it would be involved. Like a NASA rocket, Chris. Oh, I don't know. We've talked about remaking Saturn V before. I honestly don't think that would be as difficult as everybody makes it out to be. Yeah, I don't think that would be as bad as people think. Your favorite is the cigarette rocket with the jet. Yeah, dude. Yeah, that's the Freedom rocket, the flyback booster. Have you seen a Starship launch in person? Flight 7 and Flight 8, dude. Is it really as loud as reaching earache? Depends on how close you are. I watched one from, I think, 6 or 7 miles away from the roof of the Margaritaville Hotel with Das and Gene. It's pretty damn loud. I don't think you'd need hearing protection at that range, but then again, my hearing is toast anyway, so. If you were like close, like watching it from river or something, I'd bring it just in case. What does Starship normally run on? Just batteries? Yeah, batteries right now because it's not a long flight time. Heck, Falcon 9 still runs off batteries. The only thing that has solar panels on Falcon is Dragon, and because Dragon's designed to be up there for a long period of time. The first stage is going to be flying for 8 minutes, and that's it. You can make batteries last that long. Easy, right? And the second stage has enough battery life for about 6 hours after launch. Yeah. It's probably gotten better over the years, but I know it's at least 6 hours because that's how long we got Starman footage for. Remember the footage of Starman floating around on the first Falcon Heavy demo flight? Remember that? We got footage for a little bit of time, and then we stopped getting footage because the batteries ran out on the second stage. You couldn't use a form of regenerative braking in space? No force to turn a turbine in a vacuum, I'd assume. It's possible, home planet, but right now, with the spaceflight tech, with off-the-shelf spaceflight technology right now, a form of energy harvesting from re-entry is not something that is a thing. It could be done, but I think we're more focused on trying to make something get there rather than trying to scavenge energy from the flight environment, dude. SLS uses an APU, though, doesn't it? Yes and no. SLS has core stage umbilical or core stage auxiliary power unit, or CAPU for short. The CAPUs are something that the RS-25s need to work correctly. The reason why it does it is because they were supposed to be reused and they put them on an expendable rocket. So they had to keep the APU design. There's 4 CAPUs on the bottom of SLS's MPS. There was 3 on the shuttle. I don't know, Celeb, maybe. How long do you think until they finally static fire Ship 37 on the orbital pad? It's going to take some time to modify the stand, Cake. Yeah, it's going to take some time to modify that. Are you aware of any engines that have an alternator like KSP, or is that a made-up game mechanic? A nuclear thermal rocket engine, in theory, could do that. It could generate power. I'm pretty sure that's based off of a real-life rocket engine, Pashto, but it's not. It was. I forget which engine, dude. Guys, let me. This music is way too intense for this. You know what? You're right. That's a good song, but yeah. Let's switch to the chill playlist. Wait, did you say only 6 minutes or 60 minutes for second stage power? I said neither of those tech controls. It's 6 hours. I think you may be onto something with different engine mounting. You could spread it out like 4 engines per tank. Find out. We should use RTGs again. We never stopped. The Perseverance rover has an RTG on it, dude. So does Curiosity. All right. Let's check this revised design. Stage test. I'm gonna do this with heaviest part struts, just to see what happens. Our 5 stage test, switch over to the VAB. Okay. Well, they have to make the nuclear things humongous to put in a rocket. What are you talking about? No. Compact nuclear reactors are something that we can do. We've done it before. In the 60s, we launched nuclear reactors into space. The Soviet Union and the US successfully generated power in space. Arms limitations treaties prevents nukes from launching on a rocket except in very case circumstances. For instance, when Perseverance flew on Atlas in 2020, right? When it took off with Ingenuity and on board, we informed the Russians that we're launching something that has nuclear material on it, but it's not an ICBM. We informed everybody. We told everybody that we were doing that. Because we don't need their nuclear detection satellites going off and thinking we launched an ICBM or something. Anytime you launch something with nuclear power on it, you do that. Heck, anytime you launch something, you do that. All right, let's try this. I'll try a slow ramp. Let's see what it does. Jesus, it overdrives the sound so hard, man. I'm sorry, I gotta turn that down. Okay. Something like that, Hellfish, yeah. We broke off the launch mounts. All right, let's do let's do some hoppy action here. A good test was testing it on that, and I thought it broke, but it just snapped off the launch mounts, but the thing held together, which is good. This is Kerbal Constructs, Coltec. Just try to set her down and see what happens. Here we go. Same failure, interestingly enough. But that was way stronger. So yeah, it's the amount of force that we're putting on that the attachment joint. It just can't take that force. That's my theory here. Let's try to replicate the same test, see what it does. Like this, I mean, if I have plans for reusing this stage at some point, it needs to be able to survive this stuff. We need to be able to bonk it around. That's what happens when you reuse stages in Kerbal. They get bonked around.
Discovery, go at throttle up.
All right, gonna go up as fast as we can. We have why is it not showing me total thrust output? That's weird. Pulled 9 Gs, but that wasn't loading from the front and back. That's just testing the thrust structure. Thrust structure looks okay. Well, here's the thing. Look, the way I'm looking at this is that if we can't push up on this thing when it's held down on the clamps and not blow it up or like bonk it against the ground or something, we're going to have a bad day. The reason why we're going to have a bad day is because you got to remember, when this thing flies, it's not going to do that. We pulled 9 Gs there, but there was no load on the top of this thing except for aerodynamic load, but that was gone real fast because we got up to space pretty damn quick, right? And we're going to, with other versions of this, dude, this is going to have 2,000 tons of upper stage on top of it. 2,000 tons of upper stage and payload. I got to make sure that this thing works. Like this thing has to be insanely strong on basically every axis. That was good. That was good. But with that all being said, I was pretty happy with that. This thing is way stronger. I'm kind of new to KSP. What's the purpose for satellites in science mode? With the right equipment, if you put them over certain biomes on planets, like if you have one that's in a polar orbit and it goes over it goes over the North and South Pole on curve, you could take scientific data from different biomes. Train guy. Dummy second stages. I'm thinking just make the second stage. Do we need to do a static test? But after you got that stuff, the satellite's pretty useless, right? I mean, it's only as useless as you want it to be, dude. Figure out another use for it. Maybe put like a docking port on your satellite or something and make it so you can move it to another orbit or something. It's only as useless as you make it. You know what I mean? You made a single stage to orbit. Most first stages could SSTO on rockets, Chris, with the right aerodynamics. Like a Falcon 9 first stage could probably make it up there by itself. Heck, it almost makes it a third of the way there with a freaking payload and a second stage on top, and then still has enough for landing. Falcon 9 first stage, you could probably SSTO, but the thing about it is that you'd send that entire Falcon 9 first stage into space for a payload probably about the size of a shoebox. So, do with that information what you will. It broke off the clamps! It broke off the clamps! Oh! Dude, we need more clamps to hold this damn thing down. That's crazy. I mean, it only puts out 74 meganewtons of thrust out the stage, so yeah, that kind of makes sense now that I'm really thinking about it. The clamps held it down, and then one of them broke and it snapped off. The China problem. So if it's breaking off the clamps, we add more clamps. All right. I'm going to start this with it at full throttle. Ready? 3, 2, 1. Don't explode. That was awesome. That was awesome. That was awesome. That was pretty cool. May I ask what you're doing? So one train guy, I'm testing this first stage. So when all the engines are firing on this thing, dude, it is compressing the entire stage. I haven't built the second stage for this thing yet. The second stage is going to be up here somewhere, right? I haven't built it. So what I'm doing here is I am replicating the loads that would be induced on this thing with an upper stage. I kind of did some preliminary calculations, and we figured out that the second stage in payload on a rocket this size, with per the expectations, per what I'm trying to do, is going to end up being about 2,000 tons. So long story short, I'm firing the engines, and all of these are attached to the point where the second stage would be sitting. It's attached to the piece that the second stage is going to sit on top of. So if I have everything attached to the top of the rocket and I fire the bottom of the rocket, it's going to compress the whole rocket, and it's going to encounter the loads, the compression load. Basically, it's going to try to accordion itself. It's going to encounter those loads on ascent. I got to make sure that we can hold this thing down indefinitely. Because if we can't, yeah, we're going to go to launch this thing, right? We'll go to launch the damn rocket, and the first stage will try to compress itself because the second stage is being pushed on top of it because of gravity, and the first stage engines are pushing up, and it'll compress our stage. This is the thing with real rockets. They do, this gets tested all the time. The first stage, the Falcon 9 first stage test stands at McGregor. Look, that's the first stage test stand. You see how they have bungee cords that are holding the top of the vehicle down? They have the 4 hold down points down here that Falcon 9 would use on a launch pad, but this is a testing pad. So they fire the engines at full blast, right? And they basically pull down on the top of the thing to get the rocket to compress, to encounter the compression loads that it would see during a flight, right? Dude, that's the real life version of what I'm doing right now. Only I'm not doing it with a Falcon 9. We're doing this with like a super heavy. This thing is like super heavy sized. It's pretty big. Maybe you want low power first and full power halfway. So the thing is, 16K, I'm really looking for shock change. It's not that it can withstand 74 kilonewtons of thrust. I can get it to withstand, 74 meganewtons of thrust. I can get it to withstand that if we ramp the engines up. What I'm looking for is the delta T. Well, not delta T. It's your change in thrust, not change in time. I'm looking for shock load, rapid changes in thrust output. That way, if it can withstand doing this without breaking any clamps, we're still getting 24. We still have 24 clamps attached. If we can do that with 438.77 kilonewtons of thrust, then we can do this. We know that no matter what second stage we put up there, oh, we broke off a clamp. See, we're looking for shock changes. These are called shock changes. Doing this, see that? See, my accelerometer is going all funky. See, you change the frequency of those things, you start breaking clamps. So we got to be careful. But that indefinitely held that load for a long time. We were pushing up on those damn clamps with 75 meganewtons of thrust. That's a lot. That's a lot of thrust. But we pulsed it and we started breaking off clamps. Did you see that? Now, it would be nice to know what force the clamps sheared off at. I'm not 100% sure. But we have 24 of them, and it took 24 of them to hold this thing up. I'm pretty sure 24 of these clamps holding the thing down would be more than 2,000 tons force of a second stage being pushed down on it. But real rockets test for stuff like this. The reason why is because real rocket engines do what I'm talking about. Not a lot of people know about this. You know, it might look like a rocket has a constant stream of fire coming out of it, but the reality is that you do get thrust fluctuations with a rocket engine. That happens. It chugs. It can chug. That's definitely a thing. And what the thing is that if it chugs for a second, right, and you get a momentary drop in thrust, the entire plumbing of the vehicle hydraulic hammers itself. And that can create resonance up and down the vehicle. It can create harmonic resonance. It basically will vibrate itself to death.
Go and throttle up.
That longitudinal oscillation that's being induced from fluctuating thrust outputs can basically compound over time and make the whole vehicle shake like this until it blows up. What I just showed you there happened on the Saturn V. The first two flights of the Saturn V, Apollo 4 and Apollo 6, were objectively a failure because of that. They're called pogo oscillations. It's a form of harmonic resonance that's encountered with rockets because rockets don't produce a constant thrust output. It does fluctuate just a little bit. Even like a kilonewton delta of thrust change fluctuations in your motor can cause a really bad problem. There are ways to get around it. With that being said, there are ways to mitigate that. It's basically the architecture of how you design your plumbing. You have to basically turn your plumbing into a shock absorber. Yeah, that's what SpaceX was trying to do with the Block 2 Star. That's what they're trying to do with the Block 2 Starship, and they encountered this problem on Flight 7 and fixed it for Flight 8 because they figured out what part wiggled itself to death and reinforced it. Well, actually, they didn't reinforce it. They bellowed it so it actually can move easy. Well, they reinforced some parts of it. I won't talk about that. They reinforced some parts of the lines so it doesn't vibrate as much. Jerk, yeah. Mixo, you could call it jerk, yeah. I don't know what that's pertaining to, but yeah. Braking force is 150 kilonewtons. Interesting, too money. Didn't they shut down the center engine early on the second stage to minimize oscillations? Correct. Last. An engine that is working normally is largely down to the limitations of atomization of propellants. In an engine that is working normally, is that largely down to the limitations of the atomization of propellants? No, there's a lot more at play than just propellant atomization. It must be tedious digging through all the data to figure out where the failure occurred. Well, Ori, the thing about fault tree analysis with rockets is that, well, SpaceX, it's no secret that SpaceX has cameras all over their rockets. We see them all the time. You see them here. You saw there's tons of cameras on Super Heavy. You visualize everything. But here's the thing. So, like, say SpaceX had a camera inside of the LOX tank on Flight 7, and they saw the lines start to vibrate because of pogo, and they saw them snap. Well, that's all fine and dandy, but just because the line snaps doesn't necessarily mean that the line isn't strong enough. You need your telemetry. You need to take telemetry and you need to corroborate it to the visual footage that you saw to make sure that that is what's going wrong. Just because a part explodes doesn't mean that part has a design flaw in it. It could be something coming from upstream. It could be a cascading failure. That's important to understand, especially when it comes to troubleshooting rockets. In the industry, it's called fault tree analysis. That's just a nice way of saying we're troubleshooting it and figuring out what broke. But the other thing is that, you know, if Starship had a problem on Flight 7, right? It had a pogo, it had a harmonic resonance problem, right? You're not getting it back. It's not like you can go inspect the damn vehicle, right? It's long gone. It's gone, reduced to ashes, quite actually. And what's left of it washed up on a beach somewhere in the Caribbean. That's not going to be good for fault tree analysis, so you have to rely on your telemetry and your cameras to figure it out. It's much easier when you have hands on the thing that failed, when you have physical stuff. Which is why, like, Flight 4, for instance, with Booster 11, SpaceX went and fished that damn thing out of the water. I mean, it just did a soft landing, and then it sank into the Gulf of Mexico. Yeah, I'm calling it that. It sank into the Gulf, right? And they went and fished it out so they could inspect it. Even something that didn't break, it's better to have your hands on physical hardware. That is not something that anybody could do, save for the space shuttle, right? That's not something anybody could do up until SpaceX came along. Having hands on a flown booster is a big deal. Especially a flown liquid fuel booster. That's really where SpaceX came into their own. Because we had plenty of info on reusing SRBs from the shuttle program, but not much on using a liquid fuel booster, right? So SpaceX getting their parts back, just getting your parts back, is enough. Like, seeing something that has flown and getting it back is enough to not only like help you with reusability, but help you with potential fault tree analysis. It helps you with eliminating design flaws, and it helps you upgrade your design. Because up until now, every rocket that was expended, you just sent it, and then I think the telemetry is okay, whatever. You're never going to see the hardware again. Just something to consider. It's, yeah, really interesting stuff, getting your stuff back. You know, it's not only helps you with reuse, it helps you optimize your design, getting flight hardware back. Now, it's funny because the space shuttle arguably got the most flight hardware back out of any rocket, and they somehow didn't do that. But like I said, I don't think, everybody says the shuttle had design flaws. I don't think the shuttle has any design flaws. I think it was fine the way that it is. It turns out if you don't use it as intended, it's not going to work correctly. It's really weird, huh? That would be like taking a smart car and trying to go off-roading with a smart car and saying there's a design flaw because your smart car got stuck in the mud. It's a smart car. It's not a mud bogger. There's probably a reason. You're probably not using it right. Putting it out there. I mean, keep in mind, that is a very big generalization of the shuttle program, but it's no secret that there were programmatic management problems that plagued the entire program. The Gulf of Cuba, United States, and Mexico. Yeah. I just call it the Gulf. I don't care. So each one of these has a failure mode, has a failure point at 150 kilonewtons. We have 24 clamps, so let's figure out the force. 150 times 24, 3,600 kilonewtons. $3,600 kilonewtons. So we're holding it down with 367 tons of force, and it's braking. But the clamps are breaking off, so it's not. So let's do tons force. It'll be easier that way. So we need a hold down equivalent to 19,613. So 19,613 divided by 150 per clamp. We need 130 clamps to hold this down to measure to get it right. To push this thing down with the right amount of force. Let's divide that by 8x symmetry. So we need 16 times. Oh boy. You know what this has ended up looking like? It looks like the bird cage that SpaceX used to crush early Starship test articles. Oh, wrong key. Why can't you test fire it upside down? Because the rocket... Okay, 62. This is going to sound like a all smart aleck answer. It's because the rocket goes up. I mean, we could. Rockets have been tested that way, with the engine pointing straight up, like the AJ260 did that. So that's 72. I heard you like launch clamps. Put launch clamps on your launch clamps. Need to build a test stand like they have at Stennis? Kind of, yeah. I think you should test what a single can. I was basing that off of what somebody else said in chat. Let me scroll up and see if I can find it. Who said that? T-Money. Let's see. Let's check the article that T-Money made. Yeah, and the CFG for the launch clamp, the braking force is listed at 150, and the braking torque is 150 as well. All right, well, let's see. Let's see. We have 72 launch clamps holding this thing. Let's see if it breaks any of them. I think it'll hold. But once again, this is designed to compress the entire stack. To basically encounter loads that it would see with a huge Gigantor upper stage on the top. Because I don't want to send this thing off and start building the second stage and then put a second stage on top of this and try to launch it and have the whole stack explode in my face. I mean, that would probably be funny. And let's be real, it's Kerbal. We're not really doing many calculations, so it's possible that just will happen anyway. We broke off all the launch clamps, really? More launch clamps made it break. Weird. Put a set down the bottom for funsies. Help ease it in a little bit. Just tap it in. Just give it a little tappy. Tap, 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 tap-a-roo. Why are the launch clamps in series? What is the benefit versus putting 72 launch clamps in parallel? Nothing. It does. They're not in series. They're all gizmoed out into position. They're not. Toss that idea. That's not what's going on. They're not in series. One clamp isn't attached to each other. They're all attached to the fairing. Okay. It's just a visual representation because I didn't feel like clipping 72 clamps into each other. Breaking off clamps, it's gonna explode. You know what? We'll just keep it all held down. I'll just keep all the clamps together. The bottom 8 clamps aren't going to make that much of a difference. In fact, that might cause it to explode because we're not holding down the entire vehicle. Because some of the engines are attached to the damn fuel tanks. I just got here with the activity coupling. General seems to be stressful with physics engine. It's stressing out because the launch clamps are auto strut, man. And every time a clamp breaks off, it disconnects an auto strut. All right, let's just try this. Ready? This is a stupid test. I'm done with it. Fire! You put it upside down where the second stage would attach and then did hack gravity plus engine thrust. It would be the same load, right? Not exactly, John, because then you're going with the force of gravity, not against it. It's not going to be an exact analog. It would be close. But you remember, gravity's still pushing down. So if the engine's all full blast pushing into this thing plus the force of gravity, right? That's not going to be exactly the analog for this because we're going up when we launch it, not down. You deleted the fairing on the bottom. Don't worry about it. The auto struts rapidly disconnecting are what's causing the problem anyway, so. But just throw 2,000 tons of ore tanks on it and see if it explodes. Yes and no. I want to see more of this first stage because I think we are on to something. Let's try this with no auto strutting on it and see what it does. John, I think so. Yeah. Yeah, I'm not sure. I don't really know why it did something different last stream, but it was most likely something that I changed that I didn't understand that would change it. I'm getting really, really good results this time around. The biggest change that we've done, guys, is take the outer ring of engines and attach them to the fuel tanks. They're attached to the tanks instead of the center thrust puck. You have to find a way to disperse the load somehow, and that's the way we're doing it. And that seems to be promising. I started at 9:30 Seacracken. I did an auto stream this morning and then started KSP about 2 hours ago. The design doesn't suggest it thus far, but is this meant to be reusable? So Admiral, my running hypothesis here has been that, dude, to get this thing to go up, we're going to need to reinforce it to the point where it probably would survive coming back down. So wouldn't be that much more mass to put a control system on this thing, right? I'm not suggesting you do it here, but can you launch rockets that are floating in the ocean? You can do that in KSP, Halsey, yeah. If you got to get them out there somehow, but yeah, you'd have to build like a boat to move it out there, or drive it over to the water, sink it in the water, and figure out a way to do that. But it's doable. You can do it. You'd need ballast tanks to get the thing to sink down into the water, though. That is doable. You can do that. You can use ore tanks as tank ballast and change the buoyancy of something. Absolutely, that's absolutely a thing. Oh, there's also the Cove site. Yeah. I always forget that that's in game. There is a waterway. I don't know why I don't have it here unlocked in my engineering save. It's probably because I just never flew over there. Speaking of reusability, do you happen to know if there are any tutorials on landing on a pinpoint object? I know how to do it, Ori. I don't really have a tutorial per se. I do it. With that being said, I do have boosters that can boost back and land. It's really just trial and error. If you're trying to do something like Falcon 9, when you do your boost back burn, the key is to not boost back so your trajectory goes all the way to KSC. All right? When you're doing your boost back, you basically just need to stop. Right? So what I do when I flip the booster around, I don't point it back at KSC, right? I don't point it completely that way, retrograde. I point retrograde radial out, because what that does is that increases your apogee and also slows you down. You want your trajectory to basically go straight down. The reason why is because Kerbal rotates pretty fast. So if you send your first stage out, you turn it around and you point basically 45 degrees, or not 40, yeah, 45 degrees up off the horizon, and you go up instead of going backwards, right? You'll coast and KSC will rotate into position under you because Kerbin spins fast. I mean, Falcon, the real Falcon 9 does that to an extent. Watch the next time you see a Falcon 9 do a boost back burn. It is not perfectly tangent to the second stage. So if the second stage is going this way, the first stage doesn't rotate 90 degrees and go this way. It does this. It goes up and backwards. Because what Falcon 9 is doing is not boosting all the way back to the launch site, but putting its trajectory high so it sails, right? And then KSC, or wherever it's landing, rotates into position. Yeah. That's the best advice I can give. Other than that, it's just trial and error. Hey, question for you. Is this your design showcasing what a possible first stage for a post-Apollo Saturn launch vehicle, or is this a real concept? It was a real concept that actually never got off the drawing board. I've scaled the numbers into KSP and I'm building a KSP equivalent of that. But yeah, it never left the drawing board, along with a lot of other really good NASA projects. I've always wondered why, when I target KSC, I never calculate for the rotation of Kerbin. Yeah, if you boost all the way back to KSC, you're going to come down in the mountains. Yeah, because Kerbin's going to rotate underneath you. Have you tried putting dummy heavy things on the bottom plants strut to, and not the first stage? No, I have not tried that. What I have tried is what you're about to see. We'll go over it during Space News, T-Money. Well, all the clamps failed, so, you know, just separate those. Wait, so IRL payload for this guy, £1 million. 980,000 pounds projected. That's baseline. So it probably ended up being about $1 million and change. Like, what is that? 480 metric tons. It's pretty big. 18-meter fairing. Fairing is 60 feet. It's a 60-foot fairing, which is crazy. That's big. Crew 11 conference is live. I will go over it during space news, dudes. Just gonna see if we can set this thing out on the pad, see what happens. Hey, look, it SN10'd. What do you think Oklahoma wants to put on their bridges? We are designing them for 315K. Overloaded truck. Oklahoma. This is a bridge on a major highway, Plum. If it's a major highway, I would over-engineer it. I don't think that's necessarily designed for one particular thing or another. It's just if you increase your load factor on a, I mean, Plums, I don't know why I'm telling you this. Like, you already know this. But if you increase your load factor like 5-fold on a bridge, you could be sure that whatever that gets put over that thing doesn't break. Simultaneously, right, the load cycles of the bridge will last longer with a higher factor of with a higher load safety factor, right? Like, it'll last way longer because you're not putting it through a duty cycle. Basically, if the bridge is designed for 2 tons, right? If you have a bridge that's designed for 2 tons and you constantly have 1-ton cars driving over it, right? 1, that thing's never going to collapse. And 2, every time a 1-ton car drives over it, it doesn't bend it as much, so it doesn't fatigue as much. It's on a turnpike, 315,000. I just wanted to see what we could speculate on the permit they're trying to justify. If it's on a turnpike, you look at federal DOT. So right in the Plums, it's probably federal DOT standards if it's on a federal road. And here, let me give you an example. However, you're one of these bad boys. There's your answer. 2 of those on a truck, or 1 of those on a truck, like a 7-ton truck moving with a trailer, is going to be pushing 70 tons, right? 70 times 2, give or take, is about 150,000 pounds, and then 2.0 load factor. Makes perfect sense to me. I don't know, that's probably not it, but that's the heaviest thing I can think of that Uncle Sam would want to move around on a federal road. Why does EJ sound like he's in a tunnel? Because everything is making my audio screw up today, and it's pissing me off, Jack. Can you do me a favor and deal with it? Because I don't know. I don't know. I haven't changed anything. I haven't changed anything between the stream yesterday and today, and for whatever reason, everything is breaking. It's to the point where I'm getting a little annoyed. Not with you guys. I'm getting annoyed because there's no reason why this should be breaking. I haven't done anything. I haven't changed anything. In the computer, the auto stream started desyncing like crazy today, like every 30 seconds, and that just... I haven't changed anything. It's the same exact thing that it was yesterday, and for some reason it's just not working. It's really getting annoyed with that. Not with you guys. It's just... Why? It's freaking breaking. Anyway. A refresh fixed it. It's a Twitch issue. Dude, I find that Twitch does that sometimes. The way they're encoding things sometimes, like, that's completely out of my control, distorts sound. And it doesn't, I don't see it happen to any other people. I don't know if my bitrate output is good or bad, or if I'm outputting at in a format that the encoder doesn't like. I don't know. But it's intermittent, which just makes it even more annoying. It's frustrating because it's distracting. I already get distracted enough. I don't need that also distracting me. You know what I'm saying? And once again, it's not you guys. I'm not mad at you guys. It's just, I don't know what to tell you. I don't change anything and then it does different things, you know? Okay, this is too chill. Next song. You got bees, I mean bugs in the system. That audio's tight, son. Nah, I mean. Why are you testing it with full tanks landing it? Because that will put the maximum amount of force on the thrust puck. It seems like... So the thrust puck works. We can shock load it by starting 7 engines all at once, dudes. That's not a big deal. That ain't no problem. It seems like, once again, we're talking about load factor and factor of safety here. We were talking about it with bridges, though, but this is still structural engineering. It'll take all those things pulsing on it all at once, and I'm pretty confident that if we put 2,000 tons on top of this thing, it'll be okay. In fact, we can test that in a moment if you want. It'll work, but it doesn't seem like it takes much more to make it break. So it'll work, but it's just inside of being able to work from what I can tell. Once again, we're not doing any analysis or anything here, but distraction grenade. Oh, that's not you two. But yeah, we can. Here's what we'll do. Let's 288. 288. No. 2,000 divided by 288. 7 tanks. Okay. Interstage nodes on this thing. Cut them off. Hold that up. Gonna do some really basic strutting here to hold this damn thing together, because it is going to need it. And then inside of these tanks right here, Okay, well, there's our 2,000 tons and change. Our mass simulator. Let's see what happens. What is this song? This is... this song. Who thinks it's gonna blow up? You think it's gonna blow up? I think it's gonna blow up. That's exactly what I mean. Same spot failed. Guaranteed. It's the structural connection. I'm like 100% sure of this. Structural failure on linkage between Airstream protective shell and EP50 engine plate. That's gonna come back to bite us, dude. See, it's not good enough. Good enough to get the damn thing to fly by itself, but the second we put hold down points down here and put an upper stage on top of this, it's gonna crack this thing into a bajillion pieces. The other thing that we could do is just put clamps on this thing to see if it actually does do it. Hey William, how's the progress on getting stage 1 functional? Well, I still think we're a little ways off from getting it all working correctly, but we are, yeah, she's getting there. Let's see if it holds up now. Would attaching the inner ring of engines to the fuel tanks be a good idea? Just thinking it may take more stress. I mean, Scott, that might be what we need to do, man. It's possible. Yeah, it might. We might have to do that. Hey. All right. Let's see what this does. Not good. Structural failure between engine plate and the protective shell. And the fairing of the engine plate again. Look at that thing. That's a full tank of fuel getting thrown over there. Nice distance. I hate engine plates. I hate them so much. Take a shot every time there's a structural failure between the engine plate and the fairing. Trust me, you do not want to do that. Can you just get rid of them and use the tanks? Close to just doing that, Hellfish. The engine plate is the reason why this is causing so many problems. Engine plates are finicky, dude. I said that right when we first put one on. It's very finicky. But the reason why we put an engine plate on there was because we were looking for a stronger attachment for our fuel tanks. Because I didn't have any of my engines attached to the fuel tanks before. So it's possible that if we delete the engine plate, because I hate that thing, and just use an inline SRB like what we did with Neptune, right? Just use an inline SRB. Instead, that goes down to the thrust puck, right? Instead of that stupid freaking engine plate. We need an intermediate structural part. I'm not attaching the top to the bottom. That's not like in line. I don't want to do that. I'll put a Clydesdale in the center or something, dude, right? And then radial attach my tanks to the SRB. The reason why is because we're not going to use a solid rocket booster on it. It's a good brace. SRBs are just a big solid pipe. Very useful for structural design in Kerbal, because it's basically a pillar. If you take all the fuel out of it, it's a really lightweight tube that's really strong. If we do that, take the stupid engine plate out of the design and then attach the engines to the fuel tanks instead, I think we might be in business. SRB tube is tried and tested. That always works. I'm not sure how well it's going to jive with the fairing, but once again, the engine plate is not jiving with the fairing anyway, so no harm, no foul in trying it, right? The first stage reliability has improved a lot since you mounted the engines to the other fuel tanks, was just the thought. Yeah, for sure, Scott. SRBs are steel tubes, Pythos, but reference acknowledged. Ortaz, have I ever encountered a bug where the game always launches a specific craft instead of the craft you wanted to launch from the BAB? This happens on all my saves and it won't go away by resetting. That sounds like you got mods installed, because I've never encountered that problem. Ever. Yeah, we'll go to revision 6. That's what we're gonna do. Rev 6 will be fine. Fortunately, this booster is in many parts. It's really easy to take it apart and retool something. The engines, though, mean we got to redo a lot of struts around the thrust structure, but that's okay. No problem. Let's go to revision 6. July 10th. Alright, start undoing all of these struts down here. I'm telling you, man, those engine plate attachment attachments suck. I hate that thing. Alright, so now what we gotta do... we gotta just detach that, and that leaves us with the center ring, right? And now what we gotta do is just temporarily, we need to take this fairing, we need to edit it, and we just need to terminate it so it's not closed on the other fairing. Now, get rid of my strut lattice work. We're gonna have to redo it. And then get rid of this. and get rid of that. So, an old tried and tested way of doing this is how we used to make super heavy boosters back in the day. I mean, I didn't wrap them in fairings or anything, but a good way to do it was to take a gigantic SRB and put it in the center. Are we going to use that SRB? No. No. Thrust limiter 0, gimbal limiter 0, no solid rocket fuel. Get rid of it. Grandparent parts, strut that. Now, we gizmo this back to find the center point of this booster. Right around here. Right? Then you take your fairing and you attach that to the back. Just like that. Now we take that piece, that main control piece, and we put it back in position to get the engines lined up with the end marker right there. I actually think I moved it right into the right spot. That looks like a down cover. It does end up looking like super heavy, right? So now the other thing that we got to do is I'm going to move my rulers back into position. This is why I have a master craft file, because I have struts connecting between 2 cubic octaves that work as rulers. Gives me a straight edge. Edit the fairing. Toggle snap. Close the fairing. There we go. So now we take that fairing and watch. How much dry mass is a Clydesdale? So she has 123 tons of mass on it, and the booster's 144 tons, so it's 21 tons dry mass. 21 tons dry mass is inconsequential to your delta V when your booster wet mass is 2,900 tons. That's nothing. It means nothing. That's nothing. In fact, I'll pay for the extra structure. So yeah, it is a little bit of a trade-off though. The engine plate's definitely lighter, but the engine plate also doesn't work. That's an important one to don't forget that. You've been using engine plates? Yeah. I tried something a little bit different, and the engine plate auto strut is locking that tank. Oh, I don't like that. Get rid of it. Separate these. Separate the engine section and the back tanks. Look, auto strut is permanently locked. It's permanently flagged that part. Just to be absolutely sure we've rid ourselves of engine plate nonsense, I'm getting rid of that tank. And we'll replace it with a new one. A new one where we won't have to worry about that. That's what I mean, dude. Engine plates are finicky. They're finicky like that, dude. I don't like them. I never use them. I never used them until now. And to be honest, I wouldn't have told you. Like, I knew engine plates were weird, but let me just tell you this. I've been using this build to kind of remember how to play KSP. And one of the things I'm remembering is that I hate engine plates. I hate them. They're terrible because of this. because this crap happens. All right, now we can screw around with the auto strut. Grandparent part that. Let me take the next tank down here. Grandparent that. That's good. Grandparent that. Cool. Engine plates are the devil. The devil. Everything is the devil to you, mama. Well, I like school and I like football. I'm gonna keep doing them both because it makes me feel good. And by the way, chat, alligator's angry because the medulla oblongata. Did the starter stage fairings get fixed? I haven't played this game in a year on it, but I have no idea, bud. I have no clue. Putting a Clydesdale in there really puts the size of this thing into perspective. Here, I'll show you the Turbodyne engine cluster. So the Turbodyne engine cluster is a scale replica of the bottom of like a Kerbalized Saturn V. So that's, in this design, that's a Saturn V. That's what this rocket would be like. Do you want to see the Saturn? You want to get sense of scale for the Saturn V? Well, I got the picture for you. Where is that picture? I don't have it in my Apollo collection. Oh, right, whatever. There's one picture that I love that basically will tell you how big a Saturn V is. It's a picture of Von Braun standing next to it. You want to know how big a Saturn V is? That's how big a Saturn V is. And Von Braun was not a short guy. He was 6'2". He was pretty damn tall. He's a pretty big dude. So that is a pretty tall dude next to the Saturn V, and this is the only picture that conveys scale correctly. That thing is freaking huge. And remember, that's that in this design. Crazy, right? This booster, this was a real concept, guys. It was a real thing that the American Institute of Aerospace Engineers came up with in the first AIA meeting in 1964. This was a thing that engineers actually came up with. That thing. So it's not like this is some crazy sci-fi booster, right? That, you know, it's like that was from like a movie or whatever. This thing is something that the AIA wanted to make for NASA. What level of hate do you have for engine plates on an Anakin scale? Sand, sand people, or full-on Mustafar? Sand people. Engine plates are like animals, so I destroy them like animals. I hate them. Could the crawler even transport it? Yeah. Yeah, it could. Yeah, sure. So let's just think about this. The payload is 980,000 pounds, okay? So what do you think this rocket weighs dry? Well, we can get a kind of a good indicator here. So we know the first stage has 18 F1 engines in it. 18 F1s. One F1 makes 1.5 million pounds of thrust. So we have 18 of those times 1.5 gives us 27 million pounds of thrust. Basically double super heavy in real life, which is crazy. All right. So that, but that will get you, that won't get you your dry mass. That won't get you the mass of the vehicle. That gets you the mass of the vehicle when it's full, right? Following is kind of, I don't know, taking into account maybe, what do you think? Out of those 20, so it needs 27 million pounds to go up, which means the launch weight is 25. Launch weight's 25.2, so that's your full wet mass right there. Taking into account, let's say, a 99% mass fraction here. So mass fraction is how much fuel versus how much rocket is on your rocket, right? Most rockets are in the 99, so it's 99% fuel, 1% rocket. Taking that into account, right? So 25.2, right? And actually, we could figure out its TWR from that as well. So it's 27 million pounds of thrust. The vehicle fully fueled weighs 25 million pounds, and about 1 million of that is payload, right? Taking into account a 99% mass fraction, we need to figure out basically what's 1% of that, more or less. I mean, this is a very loose way to do this, but 1% of 25. Oh, the mass fraction is on there. 92. Oof. Whoa. .92 mass fraction. This thing sucks. That's really bad. 92% fuel. That's bad. That's terrible. Most rockets are in up at 99%. Like the space shuttle is that bad. Or Starship, yeah. So 25.2 times 0.92, that makes this really easy. That means that this vehicle, that gives us 23.1 million pounds of fuel, right? So it's about, the vehicle's about it's actually not too bad. 2 million pounds. Oh, that's for the first stage and second stage. I get it, because it's the slash mark. Second stage is even worse. Taking into account that worse mass fraction, not over the total of the vehicle, I'd say this thing's... That's actually not bad. Like, considering, it's pretty crappy, but considering the size, yeah, you're right. You guys are right. Considering the size, that's actually not too bad. The second stage is 90% fuel and 10% rocket. That's normally that's pretty bad, but it's possible that 0.904 is taking into account the 1 million pounds of payload. I would say that it probably is. So that's actually not too bad. I'd say this vehicle's somewhere in the ballpark at 2 to 3 million pounds, which is actually pretty damn good when you think about the size of this thing. That's pretty good. Why is having lower propellant mass fraction bad? Good question. I haven't brought that up in a little while. See that formula up there? dVg time equals G times ISP ln M1 M0. So that's the delta V formula. All right, that is Tsiolkovsky's ideal rocket equation, or just the rocket equation. That's what it's called. That is your formula for discerning range on a rocket. The more delta V you have, the further you can go. Yeah, range on a rocket, range on spacecraft is not really measured in distance, just because of basically the motion of orbital mechanics. It's measured in speed. You have to hit a certain velocity to get orbit around Earth. Distance has nothing to do with it. Distance off the surface probably has something to do with it, but that's more because there's an atmosphere in the way. So you got to go up above the atmosphere, and then you got to go fast enough to fall around the Earth, right? Delta V is a good way to figure out if you have enough speed to do that. Now, Jack, you don't need to need to get too far into equations here. Like, it's math, I know. This is Twitch Stream Share Entertainment. You don't want to do the math. We could get into delta V calculations if you want. It's not a big deal. Specifically, we're looking for that M1 over M0 in our delta V equation. So, M1 is your initial mass. M0 is your final mass. So, how much does the rocket weigh fully fueled? How much does the rocket weigh with nothing in it, with no fuel in it? And that gets divided and gets put into a logarithmic function. That's what that ln is there. What that basically states in plain English is that the relationship so how much rocket you have on your rocket versus how much fuel you have on your rocket is directly correlative to how far you can go. The worse that relationship is, i.e. a higher mass fraction. So the more rocket on your rocket means less fuel on your rocket. The worse that relationship is, the less delta V you're going to have. That's what that means. That's like that's the back part of the delta V equation explained in plain English. So the whole delta V formula can be expressed as such. So you're taking gravity, right? And you're timesing that by your specific impulse, basically how fast you can shoot gas out the back of the rocket. And that is worked in with the relationship of how much fuel you have on your rocket versus how much rocket you have on your rocket. If you have more rocket on your rocket, you're not going to go as far because you have to move more rocket around. Fuel, on the other hand, is your reaction mass. The more fuel you have on your rocket, the less rocket you have on your rocket, the further you go. That makes sense? Hey, Mayan, 73-month resub. You got the corn out on the road, dude? So, what I'm telling you guys is with this rocket, these mass fraction numbers are terrible. They're really bad. That's going to really hinder you on delta V. However, do you see the size of that damn rocket? It's 450 feet tall. It's a 45-story building. It's taller than Starship. So you're going to need a stronger material to build this. You need something stronger. Aluminum is not holding this. I mean, it might. Maybe. You might be able to make this out of aluminum. But if I had to guess, that's probably a steel casing with aluminum tanks inside of it. See how there's a fuel tank and an oxidizer tank and a fuel tank there? And they're kind of spherical? I'm going to go ahead and guess that the outer casing of this was probably steel. And that's probably why your mass fraction is so bad. However, if that was made out of aluminum, your mass fraction would be better, but the rocket probably wouldn't be able to stand up straight. Yeah. There's a reason why, there's many reasons, but one of the reasons why Starship is made out of 304X stainless is because it's freaking giant. Building aluminum rockets that big is not the best. There's trade-offs in your material science design, in the materials that you use. Steel is stronger. You can hold up stuff a lot better with steel. There's a reason why we don't make skyscrapers out of aluminum, for instance. Right? Can I propose you make a 5-engine Nerva third stage for this? Let's get the vehicle working before we work on proposals. The other thing, yeah, imagine if they managed common bulkheads. I don't know how the hell you'd do that with this thing, dude. It probably wouldn't be able to stand up unless you made everything out of steel at that point, dude. Look, your tanks are separated. They did that for structural purposes, and probably because CBHs weren't really a thing just yet. I mean, that's what I mean. That's a lot of rocket and not a lot of fuel. Like, once again, most rockets flying today, guys, are up in the 98s, 99s. In fact, most of them are 99 plus. Falcon 9, first stage, second stage, mostly fuel. It's mostly fuel with a tiny little engine attached to the back. Well, tiny, but you get the idea. That's what I mean. Take a bulkhead out and fill that empty space. Yeah. Was the N1 the only rocket that used only spherical fuel tanks out of curiosity? My guess is that that's the structural problem that Korolev ran into, yeah. I'm telling you guys, the Saturn V introducing a common bulkhead on the S2 and S4 stages are really what saved that design. And now common bulkheads are used all over the place. Instead of having two tanks stacked on top of each other, the top of this tank is the bottom of the other tank. Starship does that. Falcon does that. Well, Atlas does not do that. Vulcan does, though. That's called a common bulkhead. That basically makes it so you could put less rocket on your rocket and achieve the same result. Make sense? Perfectly spherical tanks aren't the worst idea, though, Sea Kraken. I mean, the other reason why the N1 used those is because he needed room for the plumbing for all the damn engines. So having those spaces between the spherical tanks was enough you fill it up with the plumbing for the engines. So take a look. Look at the N1's design. You notice the N1 has these nacelles all around it. What those are the downcomers for the engines. So this is a render from Anatoly Zak, but see the pipes? External downcomers. Simplified the design. Not the stupidest idea when you're using that many freaking engines. Using Wikipedia numbers, Starship Super Heavy is 0.925, so pretty comparable. It's pretty bad, Admiral, yeah. Why do you think SpaceX is trying to squeeze so much performance out of Raptor 3? And trying to simplify and add lightness to Raptor 3's design? Because using stainless steel is really good, and the reason why they wanted to use stainless steel, or the biggest reason why I think SpaceX is using stainless for Starship's design, is because there's a lot of it. You can buy a lot of stainless steel. Stainless is not nearly as expensive as the aluminum. So remember how I always say that part of SpaceX's systems engineering for Starship is being able to make it mass producible. That's why they switched to steel, right? There are trade-offs. There's a benefit. You can buy more steel. But stainless steel is easier to buy, cheaper to buy than aluminum is, right? It's also apparently easier to work with. I personally don't necessarily think that, but it's easier to work with in the application of building rockets, right? So it also has the benefit of only having hoop stress, which is twice as strong longitudinal stress by math. Yeah, there you go. Yeah, sure. There were many reasons, but one of the downsides of that is that stainless steel is denser because it's steel. It's not aluminum. Aluminum's really light, right? You pay for the strength necessary for this sort of structure. Bingo. Now, Admiral, think about the Saturn V for a second. Saturn V is all aluminum. Can you believe that? How the hell did that thing fly? Really? How did that fly? I'd be curious what the tank wall thickness on an S1C is. I'll bet you it's pretty damn thick. I'll bet you the S1C on the Saturn V is pretty crappy mass fraction. Mass fraction really, I mean, it comes into play on every part of the rocket, any part of the rocket that flies, but it really makes a difference with your upper stages. The less things you can put on your upper stage means more payload you can put on your upper stage. Impressive for sure. I wonder if the Saturn V is somewhere near the practical limits for an aluminum vehicle. I would guess it's probably near the upper limits, Admiral. Yeah. Any bigger, yeah, you probably want to consider other materials. That's not to say that you couldn't make an aluminum, like 20-meter core rocket. It's doable. You could do it. That would be hard to do. Harder to do, I'll say. It's not impossible. Of course you could make it, but it might be to the point where you have to make your aluminum so damn thick, right, that the lightness of aluminum, the low density, the low mass of aluminum might push against steel. There might be a certain convergence point at size of vehicles. Robert Truax, a famous engineer from the 60s, thought this. That's the reason why Sea Dragon exists. That was his thinking. Like, at a certain point, aluminum just doesn't make sense. You lose any benefit of the lightness because it has to be so damn thick because you have a huge rocket. So why not just build it out of steel and give it a big freaking engine and brute force that sucker into space? Not a bad idea. It's actually pretty smart. That's, as you know, SpaceX would put it, Elon would put it, that's delightfully counterintuitive. It's not the stupidest thing around. Did the Saturn use iso-ortho grids? Nope, wasn't invented yet, Talon. Saturn V used aluminum panels hand welded into a barrel segment, right? And they actually put internal stringers on it. They welded baffling and stringers manually into the tanks. Yeah. Crazy, right? Aluminum is difficult to weld because you have to control the heat, but you also have to control the heat with stainless, but it's kind of for different reasons, but you also have to do that. Stainless steel likes to warp with high heat. Aluminum just melts with high heat. How did nothing explode? I don't know, King. I don't get it. Like, the more I read about the Saturn V, the more I'm just like, how did you make this with a bunch of people actually drawing blueprints? How the hell is that possible? How'd you do that? How did they do that? Dude, the thing was for the most part made by hand.
Discovery, go and throttle up.
I mean, they had machine tools and stuff for sure, but even the machine tools were like a lathe and a mill, in a press. They're all controlled by hand. The Saturn V's are freaking handmade. How was that? How was any QC correct? Like, how could you be sure that one Saturn V was different than another one? Like, it's actually baffling to me. Like, that's ridiculous. How did you get that thing to fly so many times successfully and not have just crazy problems? I mean, the truth to that is that they never really worked out all the kinks and they got kind of lucky, but also at the same time, it's pretty damn impressive. They launched, let's see, how many launches worked? Every launch of the Saturn V worked. I mean, some of them just were a little more rowdy than others. Apollo 4, despite almost shaking itself to pieces, made it into space. So did 6. So did 8, so did 9, so did 10, so did 11, so did 12, 13, 14, 15, 16, and 17. That's crazy, dude. That's crazy that they got it. Like, that's crazy that they were able to achieve that level of quality control. That's really impressive, considering everything is being hand-tooled. That's ridiculous. It's crazy. What a freaking effort, dude. What a freaking effort, man. It's monumental. Like that, I don't even have a word to describe how nuts that actually is. Measuring tools were surprisingly good in the 60s despite being by hand. Well, Ori, clearly there's clearly you're not wrong, dude, you know? Like, what was the shuttle made out of? Aircraft grade aluminum. And Chris, if your next question is, did the shuttle have a good mass fraction? The answer is no, absolutely not. How much fuel is on the space shuttle? How much shuttle is on the space shuttle? Yeah, no, the space shuttle's mass fraction was so ridiculously bad that the only way to get that thing into a relatively compact size and not build something like ridiculously big like this was to put solid rocket boosters on the side and brute force that sucker into space, which is basically what every shuttle launch was. Yeah, there's a reason why there's solids on the sides of the shuttle, and it's not just to use the ICBM stockpile of solid rocket fuel. Dude, you need an insane amount of thrust to move that thing upright. Crazy. Each SRB on the space shuttle produced about 12,000 kilonewtons of thrust. So that's almost 3 million pounds per booster. The two SRBs on the sides of the space shuttle are pretty much as powerful as the Saturn V first stage. It's a little bit less power. Saturn V had 5 engines at 1.5 million pounds of thrust per. The space shuttle has actually, yeah, the space shuttle has 2 SRBs that are basically 3 million pounds of thrust. So the Saturn V liftoff thrust was 7.5 million pounds. The shuttle with just the SRBs is closer to 6. It's pretty nuts, dude. Dude, can you imagine how big of a liquid fuel booster you'd need if you had 2 liquid fuel boosters on the side of the shuttle? It would be gigantic. It would look ridiculous, first of all. But yeah, crazy, right? That was the only way. That was the only way to get the energy density that you need to brute force that thing up into space, because the shuttle flew like trash. It was terrible. But it's not an airplane. That's why it flies terribly. It's a spacecraft first and then a plane second. I used to say all the time when we worked on shuttles, there's a reason why they call them space planes and not plane spaces. Why did the Soviets never really develop solid rockets? And when they did, why did they not develop larger SRBs? King, all the designers from the OKBs, from all the design bureaus, hated SRBs. They didn't like them. They didn't like them. I'm serious. That's the reason. The engineers of all the aerospace design bureaus in the Soviet Union didn't. They all agreed that they didn't like solid rocket boosters. This is modded KSP? Nope. This is pretty much stock KSP with the 2 DLCs. I have 1 modded part that I put in the game, or 2 modded parts here, but we're not using them for this build. This is completely stock with the 2 DLCs. I have some visual mods for like when we're flying around in space and stuff. But yeah, in terms of gameplay, it's exactly the same as KSP with the 2 DLCs, dude. They had to fit everything to go through tunnel. Harder to get SRB segments through tunnels. We didn't have any problem doing that. Oh, you can build, Andrew, you can build as big as you want. You've got to make sure, I mean, this booster has been having some problems. With that being said, guys, I'm going to get back to it. I need to... Was the Aerojet 260 designed for the Saturn V? No. The AJ260 was designed for the Saturn 1B. It was supposed to be the new Saturn 1B first stage. They were going to put that underneath an S4B-200 and have a solid rocket fuel first stage for the Saturn 1B to replace the cluster of fuel tanks that they were using. Cluster of leftover fuel tanks from the Jupiter and Juno tooling lines. It's a true story. Good luck in the build. Gotta study. Go. Let's get back to it, dudes. Okay, that's the outer ring of struts there. Now we got to do the inner ring of struts here. So once again, this got rid of the engine plate in the center and replaced it with a Clydesdale SRB. Once again, we are not putting that in the stage. Good, but not going to. Wasn't there a plan for a massive SRB for the Saturn V? The interim plans for upgrading the Saturn V through its useful end of life was basically attaching 4 Titan III SRBs on the sides of it and sending it. I believe that's called Saturn Int 20, INT20, I think. It's been a while. I think that's what it's called off the top of my head. I don't remember. That all aligned now? Yes, it is. Good. Okay. "19 engines, Pigeon. But the engines have a little bit of spice added to them. So these 19 engines produce, they produce like 74 meganewtons, 75 meganewtons of thrust, something like that.
Discovery, go at throttle up.
Box of pins, 48-month resub. Thanks, man. All right, let me lock in for a second here, dudes. I love talking with you guys about this stuff. I could do it all day. We could do it more during Space News if you have more questions about this stuff. Strut is perfectly straight. I always say this, but I'll say it again. I always take the time to make the struts look right. Because if I see a strut that's not perfectly lined up, I know that it's not supposed to be there. It's kind of an internal form of quality control that I use to keep stuff right in my head. The strut ain't right, I probably didn't place it. Because sometimes if you take stuff apart, you move a part around, you move something by accident, the struts are crooked, that means you made a mistake. It's a really good kind of visual aid that I use for making sure my stuff is right. That strut ain't right, boy, I tell you what. All right, that's the bare minimum struts that I think we need down here. Yep. We don't need to run nearly as many struts. What I do want is to run a singular set of struts from here to the tanks just to help take load off of the thrust puck. Because that fairing is acting as my thrust puck. That's my thrust structure. All right. And just put one reinforcement down here on the aft skirt. Actually, you know what? The whole night we've been running into tanks that end up being too rigid. So let's go Prometheus tank test. And let's follow our testing preparation. Right, so get rid of that. Tank test, save. Let's attach the same probe core to the front of this, the same batteries in the same exact spot. I'm going to put a heaviest part auto strut on this thing. Like what we've been doing. Just out of curiosity, I want to see what happens. Now, the SRB will still show up in staging, guys, but it doesn't do anything. That Clydesdale that we're using for structure has no the thrust limiter's 0, it has no gimbal, and it has no fuel in it. So it'll just... And that's about it. Let me just make sure that these still have the motor overclocks on them. Yes, they do. Okay. Save. Flip this over into the VAB. Let's put it out on the test stand and watch it explode. Remember, I didn't strut anything with this design. I'm trying to see, like, if the thing will survive the way it is. I think putting the Clydesdale in there did structurally reinforce things, but without any fairing struts or anything, I think it's gonna break a little bit, but we'll see. We'll see. What I'm after is seeing if the structural point between the Clydesdale and the fairings, I'm trying to see if it survives. This might just hold together, or it might just blow up on the pad. Who knows? Hey, Chief. What's going on, buddy? Flip the SRB and use it during stage separation. Nah, no, I'm good. You just got home from work, Chief. How are you? I'm all right, man. So it's gonna blow up. What did it blow up? Fuel tanks. Nothing about a Clydesdale breaking, though. Let's go back into its master file and add the struts. Interesting. What is even the use case for something this huge? So, Andrew, a couple of things. What's the use case for it? I don't know. Would I recommend a newer player building something for fun? No. You build for a use case. You build for a reason. Rocket exists for a reason. Space Shuttle existed for a very specific set of goals. So did the Saturn V, right? I'm building this to kind of get back into playing KSP. I haven't played KSP in a long time. So I'm building it to kind of relearn building technique and stuff. Just make sure it's right in my head before we start doing more, like, not less grandiose stuff, but not more realistic stuff either, but, you know, more use case driven rockets. Now, with all that being said, Andrew, this rocket should be able to put about 250 tons into orbit when we're done. When we're all said and done, that's one of my goals. It has a 10-meter fairing, and it can move 250 tons. I'd be hard-pressed to figure out if you can't find a good use for a rocket that can move 250 tons in one shot, I don't know what to tell you, man. Can't find a use for something like that. I don't know what to tell you, brother, you know? But if you're newer to Kerbal, you should be building for a reason. Your rocket needs to do something. You need to figure out what your rocket needs to do. Design requirements are very, very important. Why is there an alcoholic horse in our rocket? It's the name for one of the solid rocket boosters in game, dude. I mean, guys, so think about it like this. The real-life rocket could put over 450 tons into low Earth orbit in an 18-meter fairing, 60-foot fairing. This rocket right here, no, not that one. That's the N1. This rocket right there, the baseline vehicle, that could put the ISS into orbit in one shot. Yeah. The fairing is almost big enough to have, like, the ISS, like, folded out. Like, yeah, I mean, you'd still have to assemble the whole damn thing when you were up there, but this could put all the ISS modules into orbit in one shot. Yeah, it could easily do that. The ISS is 400 tons. This thing can move 450 plus. It would put it into space. The second stage could get the entire ISS to a 400 by 400 altitude if this rocket existed in real life. Think about that one for a second. Noodle on it. It took the space shuttle 35 assembly missions to build that thing. One shot is cheaper than multiple trips, right? It depends. The space shuttle was touted to be reusable, so 35 assembly flights flying at once a week wouldn't have taken very long in real life, Ori, right? But remember how I said a little while ago that the shuttle wasn't really operated correctly. You know, you don't go off-roading in a smart car, right? And then blame the smart car for getting stuck in the mud, right? When you don't use the space shuttle like how it was intended, it ends up getting very expensive. Right? So in this particular case, with the way the shuttle was operating, launching 1 to 2 times a year instead of 1 to 2 times a month, yeah, the 35 assembly flights ended up being really frigging expensive. They ended up being really expensive. This thing, to the point where it probably would have pushed on costs with this launching once. Don't get me wrong, that thing would have been expensive to make. Sure. As expensive as 35 shuttle missions in the late 2000s? Probably not. Nope, probably not. Hey Achilles, 51-month resub. Thanks, man. All right, let me do some strut work in here. Okay. Now let's find the middle of the Clydesdale and run another set of struts. Same exact config. Give me 1 second, guys. I got a message. All right. You are fired. Oh, sorry. We still won lunch. Okay. That was all the struts that I ran for the previous design, dudes. Okay, let's save the mastercraft file and then go back to tank test, save, overwrite it, and let's put her out on the stand again, dudes. Let's see what happens. I know this busts your analogy, but the Smart 4.2 is too hard not to share. It's the one that was made by Grindhard, I know. That doesn't bust my analogy. That's like making a highly bespoke version of the shuttle that's designed to do what you want, i.e. Columbia with the EDO palette. And that ended real well, didn't it? With that being said, that is pretty cool. With all that being said, man, it's still pretty neat. All right, dudes. New structures being added to the back of the BQD. I see it, man. I have Starbase Live up. See it over there? Space Noodles, I joined late. Just wondering, what is the purpose of the Clydesdale? Structure. Space Noodles. If you take the Clydesdale, if you take a solid rocket booster and you take all the fuel out of it, it's just a big pipe. Very strong. A column is one of the strongest forms of structural support. Structure. That's really what it's for. An empty Clydesdale is heavy. Milo, the vehicle weighs 2,900 tons. I'm not really worried about an extra 20 tons of structure. I think it's an inconsequential amount of change to the Delta V, i.e. that won't be the difference between the stage making it into space and not. You know what I mean? 37 got more engines today, getting pretty close to static fire day. That's the good, dude. Trey, if you told me after right after Massey's exploded, that SpaceX would just modify a transport stand and put it on pad A, I would have said, I did, because people did ask me, and I said no. I was like, I don't think they'd do that. I think they should just rebuild Massey's and go. You know what? I'm really happy that I was wrong, because this is way cooler than what I thought they were going to do. Now, don't get me wrong. I still got the rebuild Massey's quick part right. I said that they're going to rebuild Massey's and they're going to try to get it done quick, which is what they're doing. Don't explode. Yeah. But also at the same time, yeah, pretty sweet. It's going to be cool seeing that on the stand. Those fuel tanks are jostling around. You didn't say please don't explode. Oh, you forgot to say please. Still wish we got a milk stool. This is kind of like, it's kind of like that. You know, one set of struts at a time. Put it out again. My fuel tanks, because we're dealing with a slightly different attachment node. We're not node attached, we're radial attached now. My fuel tanks are dealing with a little bit of they're weeble wobbling around. The engine plate did keep the fuel tanks in place, but it broke the entire damn rocket. So my fuel tank stayed in place, but that's about it. Those struts that I added up at the top are to prevent the tanks when the vehicle loads, to prevent the tanks from kicking out. It prevents them from pivoting because there's struts attached to the top. It should keep them nice and true. Let's see if that fixes it. Flight in late. I want to see a flight in late July, early August. I mean, Trey, I did say that. I did say flight at the end of July, and people said I was nuts. I said it on Flame Trench, and even more people said I was nuts. Hey, Older Buffalo, 5 subs, thank you. Appreciate you, buddy. Thank you very much. Bolek.
Discovery, go at throttle up.
10-month resub. Oh, baby. Chat, look at this. All right. Ready? Damn. Woo! That was a hell of an explosion. Okay. I know what we need to do now. Looks like the rocket's coming along. Well, it wasn't coming, it was going. It went somewhere. It didn't go very far, but it went somewhere. Well, that last thing said that we were having trouble. Yes, these things, the S3, S4 adapters, were hitting something. They collided into a fairing, which means those are what broke first. So, because we're not dealing with the weird jankiness of the freaking engine plate in the first place, we should be able to just reinforce it down here and... This actually, I'm pretty sure this should make this work. I mean, once again, I have this in the test file so we can do some rapid prototyping, but the behavior that I'm seeing from KSP right now is much more with the consistent behavior that I'm used to, if that sounds right. That engine plate was really throwing me for a curveball. I'm pretty sure that's why we were getting such inconsistent, quote-unquote, data. Like, our physics simulation was very bad. It wasn't really working well. So I'm adding the original strut reinforcement web that I had down here. And yeah, it is a little bit more parts, whatever. I don't care. This is the way I know. Let's see if it pops now. Like I said, this thing is acting much more, I want to say predictably, but yeah, it's not snapping the back of the vehicle. What's happening is we're pushing up on those things and they're moving around. We're pushing up on the motors and they're moving around a little bit. What failed? The bottom, the thrust structure failed, which is why I just reinforced the thrust structure. That's what I mean about predictable behavior. Before, with the other design with the engine plate, we reinforce the thrust structure, it just blows up. You take the struts off and it works, but then it still blows up later. Like, that's what I mean about predictable behavior. What's the part count with this revision? We're below 200 parts. I know we're below 200 parts. The game just had to make me look stupid. It just had to make me look stupid, didn't it? I just said the behavior was more predictable, and then I added more struts and it blows up. It just had to do it. Hey Audrey, how are you? I swear this game listens to me, dude. It listens. The game can hear you. Alright, I'm gonna keep the thrust structure, but I'll get rid of those. Let's keep my original thrust structure down there. Those were just reinforcement struts holding everything together. Let's see if just my thrust structure makes this thing work. I used to be able to beat the Kraken, dude. There was a time where I could just build it and it would just work. But I'm rusty. What do you want? I don't use rigid attachment invisible. I like having the parts in KSP to have some flex. Because if they end up trying to stay rigid, they end up breaking a lot easier. I really haven't found a good need for that at all. The Kraken doesn't sting, the Kraken bites. Gotcha. Nice try though. Yeah. Fuel tanks popped again, dudes. I think the fuel tanks are flexing inward and that's snapping the radial attachment point. So some crossbar struts like this to make sure all the fuel tanks stay clustered together and they don't move independently of the vehicle, I think is what we're looking for. Once again, because you got to remember, if we node attachment, if we node attach this like we did it on an engine plate, the attachment node's up there. The point of attachment's up at the top of the tank. But we didn't. We radially attached them, which means my attachment point is mid on the side of the tank. Because the Clydesdale is here, and we snapped attached it. When that happens, it attaches in the center. So when we're pushing up with these engines, it's tilting my tanks in. The reason why one of the first fixes, well, quote-unquote hot fixes that I did was strut all the tanks together internally like this. See that? I strutted them all together internally to make a crossbar that holds everything together to make sure the tanks don't push in to break that radial attachment point. In fact, actually, the tighter we make that, the stronger it's going to be. Yeah. So if we just make it look like a crossbar, that's going to be real strong. So this is your own version of a Saturn V successor. It's not necessarily my own version, Audrey. We found an NTRS report that said that kind of gave some preliminary details about what they were looking for after the Saturn and the Nova rocket reached their end of life. Basically, if the Saturn V was the Apollo program's Falcon 9, this is the Apollo program's Super Heavy. Does that make sense? Think about it like this. The Saturn 1B is Falcon 1. Okay. Saturn V is Falcon 9. That was the workhorse of the program. This is where they wanted to go. This is their Super Heavy. That's the next generation rocket. 65-foot core diameter in the first stage, 60 in the second stage, 60-foot payload fairing, 460 feet tall, 18 F1 engines in the first stage. And just like we do a Wings Wednesday back in the day, I took these numbers and scaled them for KSP, and what's the result? Nova's Falcon Heavy. Yeah, exactly. At least that's from reading this paper, Aqualex, that very much seems like what they were thinking. I think the tanks need to be able to move every time it works. They're sort of bouncing around inside. Well, John, that was when they were attached to the engine plate, not when they were attached on a radial. We have a different attachment point. My theory is that with a radial attachment point as opposed to a node attachment point, we're gonna have to reinforce them to an extent. How difficult would a Falcon Heavy style Saturn V be? Would it be actually bad? How difficult? You'd need to completely redesign the pad. There's no way that's fitting in the flame trench at 39. It's doable. I'm pretty sure the Apollo engineers could have figured out how to bolt 3 of those things together. But what launch pad are you using to launch that? You got to think about that stuff when you think about upgrades for rockets. Same error every time. Guys, we might, Clydesdale might be a dead end, dudes. Never played KSP, so stupid question. Why does it look like the fuel tanks are clipping into each other? Shouldn't game physics have a problem with that? No, you can clip parts inside each other in KSP. There's no fluid dynamics going on here, Hugo. This is just a fuel tank is just a cylinder shape with a number of fuel in it. The liquids inside are abstracted. You could clip like 20 fuel tanks into each other if you really want to. Now, I don't do that, but I know from looking at it, it looks like these are clipped, but I have a little bit of a kind of an internal rule here. I clip those fuel tanks together, but those are all inside of a much bigger fuel tank. Now think about it like this. So whenever you have a cluster designed like this, the volume of fuel that gets taken up from the overlapping part of the tank is equal to the amount of empty space that I have inside of the tank. So in my mind, that's a good justification for doing it. You see how the wall, that strut is in the fairing, the outer wall of this. I used a fairing. You can make different shapes with the fairings. I used the fairing to make an outer tank wall. That's how I get around, like in my mind, the game ethics of putting this together in clipping fuel tanks, dude. But yeah, here you go. Generally, Kerbal doesn't care. Here, this works, maybe some inspiration. Yeah, the thrust structure that you made. That thing's cool, Xerax. I don't know if I want to do that, dude. It's really not what I'm going for. Great question, but would your hybrid tech bearings help? Using some form of same vessel interaction to get this thing to jive well has been proposed by other viewers, Erudite. I'm looking to not do that, though. Why are you overlapping the fuel tanks? I just answered that a second ago, dude. Attach the engines to the SRB. Yeah. Maybe, dude. I don't know. I thought the Clydesdale would fix this problem, but clearly it doesn't. It's a Gezo. You still spacing it up all the time, dude. Every day, brother. Worked on the car today too, man. I finally made the driver's side frame rail extension, that last piece that I need, and then we just got to do the tabs and everything for it, and we're gonna be sitting pretty, man. We'll do that tomorrow. I'll probably do that tomorrow morning. See, now, guys, I'm not sure what to do here. I have some other tricks up my sleeve, but I am not 100% sure if they're going to work very well. 512 tank collided into the... What do you think about Felix from What About It? I don't know, man. I'm kind of indifferent, dude. I don't really watch his content too much. That's not working, dudes. So I'm thinking, all right, where could we go with this? We could try an engine plate with the Clydesdale attached to it. That might do it. That might fix things. I wouldn't be against trying that. Doing the engine plate with a Clydesdale behind it. But how do we know that it's not just going to snap the Clydesdale in half? Just like it was snapping the connection between the engine plate and the fairing in half. Might be okay, might not. Don't know. That is a viable pathway for changing around the structure of the booster. In fact, that's probably the next one that we'll try. I have one more idea in my head that I can think of. Another pathway, another engineering pathway for this. The fairings have interstage attachment nodes. We need all of my tanks node attached. We clearly can't use an engine plate because it breaks things, right? This is like the final boss thing. Like if the engine plate with the Clydesdale doesn't work, this is probably what I'll try. I'll use the interstage nodes and then manually place each tank in 6x symmetry. Manually place each tank stack in 6x sim based off of an interstage attachment node from the fairings. And then strut the hell out of everything together. The reason why I don't want to try that right now, right, is because if you do that, you're getting rid of grandparent part strutting over symmetry. And I'll have to run a ton of manual struts in its place. If you grandparent 2 parts over symmetry, it makes a web for you of struts. Cats, they've been lurking for a bit. I had a thought. Could your choice of engine be the cause of the problem? Would a different engine be the solution? No, not really. These are overclocked engines. They're overclocked. I need to produce... We need to produce about 75 meganewtons of thrust. It doesn't really matter how we do it. I overclock these engines to keep the engine configuration similar to its real-life counterpart. And that's kind of the cause, that's kind of the problem here. I have to be able to make this thing withstand the shock load of 18 of these turning on with 3,300 kilonewtons of thrust each, right? We gotta survive the shock load. Actually, I have 19, but right. The problem is lighting all the engines all at once is basically like hitting the bottom of the thing with a giant sledgehammer, and that's what's causing stuff to break. That's why I'm trying to reinforce stuff as best as I can. What is an engine plate? An engine plate is a piece in the coupling category where it's supposed to be. The devs were trying to build different thrust structures. See how you can change it so you can change your engine configuration. The problem with engine plates is that they're not consistent. Anytime we run into this thing, engine plates blow up. Can you cal the startup? We could stagger the ignition mutter, but yeah, I suppose we could, but frankly, I just don't think a staggered ignition is robust enough because there are other times where we're going to need to shock load it. Staggering the ignition at startup is I'll find it dandy. But what about if I want the booster to be reused and I want it to come back down and land? Like, we're going to need to start the engines up, and we're going to need to do them quick. We don't have time for staggered ignition. And I'm not sure that Kerbal's going to make a difference with offsetting it by like a millisecond like they do in real life. I mean, once again, we could test it. But also, I'm looking for a certain factor of safety here. I want to be... We could do a sequenced ignition. We can do that. We could figure that out. With a cal, that's no problem. But also, at the same time... But also, at the same time... shock loading this and testing it this way, basically by beating the snot out of the booster. If it can survive this, we'll know a staggered ignition will work, and we can be damn sure that if we put an upper stage on top of this thing, that's going to be okay as well, right? Staggered ignition. Yeah, X-Wing, that's what we're talking about, an ignition sequence. That's what they do in real life. They don't start up all the engines all at once. They're staggered. They start one and then the next one and then the next one with probably about a couple milliseconds of delay. That prevents basically all the engines from overpressurizing and pushing on the bottom of the booster all at once. If you tried to start super heavy, if you tried to start all 33 engines all at once, it would explode. For what it's worth, they also stagger shutdown. Yeah, if you watch like main engine cutoff on a Falcon 9 mission, they shut down the engines in sequence. They're shut down and started in sequence, dude. Yeah, to prevent crazy loading and unloading of the first stage. That should help us here, but once again, what this stage is going to get put through, especially with an upper stage and a payload fairing on top of it, I want to be able to start all the engines all at once like this and not have it explode. You're never going to Mars on your time frame. Andrew, that doesn't make a difference. Yes, if you're using an SRB for structure, it doesn't know the difference. When you say not explode, maybe just a little bit of explode? Yeah. You always want a little bit of explosion with a rocket launch. You want a little bit of explosion to come out the bottom. You don't want it to come out the sides. That's the problem we're having. My explosion isn't all coming out of the bottom, it's coming out the sides. That generally is bad for a rocket. Yeah, right. Yeah, I've never tried it, just asking. I understand, Andrew. Yeah, a lot of you guys are newer to this, so. It's all good. I'm getting a little frustrated that... I'm getting a little frustrated because it's to the point where, like, I haven't played it in so long, I forget some of the tricks. I used to, like I said, guys, you go back to, like, 2022, I could build this thing probably in a day. Maybe a week for the entire stack. Yeah, we could just belt stuff out, dude. I built crazy things. Some stuff I don't frankly remember how I built it. But we still have the craft files and everything, so you could go figure it out. But, you know, sometimes it's about placing the right part at the right time. You know, it's about the method of putting it together. Thanks, Starpath. We should look at those craft files now. That you misunderstood. No, that's not what I'm talking about. The craft files. I'm not talking about the individual craft files. You missed the point completely. Not trying to be mean. What I'm saying is that I would have known what tricks to do to get this thing to work right off the bat. And now I have to kind of relearn what works and what doesn't work. We're learning that radial attachment points don't work very well. I'd nominate Stratton-Blitz for that title as impressive as my builds are. Yeah, maybe. Stratton's pretty damn good, dude. Fuel tank's bumping into the fairings. That is what's happening, Chris. It's because the fuel tanks are breaking off inside of the fairing and they're bouncing around and hitting it. That's what's causing the problem. Let's go back to revision 5. And I'm gonna make revision 6 didn't work, so we'll go to R7. Okay, so the solution that I had with this thing was to I mean, we need to get rid of that. We need to get rid of those. So let's take these, move these out like that. And we were getting a break between this and that. I didn't click on that. That's not what I clicked on. I clicked on the edit fairing button, game. That's really weird. Really wish, you didn't do that, because it's not like this is a hard enough problem to solve anyway, right? I'm going to move the fuel tanks out of the way because I need to temporarily detach this, right? And we also got to get rid of that strut, that strut, that strut, and that strut. Okay. And also those because they're attached to the fairings. I need any struts that are going to fairings. We need to get rid of them, like that one and that one. That one, because we got to retool this real quick. All right, so let's go over here like this and hit edit fairing. Just complete the fairing right there.
Discovery, go at throttle up.
I didn't click on that fuel tank, but that's cool that you duplicated it. All right, so here's what we do. We undo those, right? I'm going to move my engine plate up here. Gotta get rid of those two. I'm gonna move the plate up there, and we're gonna take our Clydesdale again. That's a Pollux, I don't want that. Hey, Desecray, 65-month resub. What's up? I don't know, guys. Should we attach the... Yeah, let's attach it to the mount. We know that it doesn't matter. We can attach it to either one. Get rid of all the solid fuel. We're just using it as structure. Auto strut is locked to grandparent part. Now take this, attach that to the bottom of the Clydesdale, and take those and move them back into position. There we go. And some of the struts got screwed up, so we're going to have to replace them. But that's fine. That's okay. Okay, fine. Now the next thing we got to do this is going to reinforce. Instead of one attachment point between the engine plate and that one, we have two attachment points. So my theory here is that one attachment point can only take so much jolt, right, from the engines. Which is what was causing this thing to break, right? Now, because we have the Clydesdale in between, we have the engine plate attached to the Clydesdale. That's one attachment point there, and then the back fairing is attached to the back of the Clydesdale. That's another attachment point there. So we have two attachment points in line. If attachment points between things have a maximum load, right? If they have a maximum load, we just doubled. We should have theoretically just doubled it. So we'll see what happens. Let me switch the playlist up. This song is Big Sad. Question, how long are your longest struts? Are they pushing the limit? No, they're not very long at all. Let's go here. Now we gotta redo this fairing. Gotta edit the bad boy. This fairing needs to be solid. I mean, you can gizmo them to be longer than they need to be, Aqualex, but I generally don't do that because you're going to run into some float point errors. You know how, like, sometimes when you have a craft up in space and you dock two crafts together and one of them starts freaking out and explodes? That happens from auto struts running too far. So, like, if you have an auto strut that's on your vehicle and it's heaviest part, right, and you attach something, and now it's gonna run the auto strut to something else on your space station, if it runs the strut too far down the hierarchy, it blows up. It'll go right to your thighs, and then you'll blow up. All right. To avoid auto strut to heaviest? I mean, Toothless, that's not really the context of what we were talking about, but yes. Yes, I generally avoid those. Yeah, as much as possible, dude. Toothless, do you remember, like, leading right up to KSP 2? Or, well, that other game that we won't talk about? I built the 5th generation shuttle, and then I used it to build the space station. Do you remember that? I made the space station modules out of stainless fairings so they look nice and shiny, and then I used the shuttle's robotic arm. This was not like the one that I did in 2016. This was much more recent, right? Do you remember that, dude? When I put that station together, I was keeping track of where auto struts were being run through the entire design. The station had to be put together in a very specific way. If you didn't assemble, I came up with an assembly order because I was so dang worried about a random heaviest part auto strut or even a grandparent auto strut being run in the wrong direction. Yeah, it took me a while to engineer that. But yeah, I was keeping track of the hierarchy in my head as we built the station, so we never had to worry about a Kraken strike. I ended up building the whole damn station, and one glitch in the game broke the robotic arm, and because we reversed the flow of the hierarchy. I missed one thing out of a 500 part station. I missed one connection. Damn. Have you been keeping up with KSA? I'm a consultant on KSA Starpath. Yeah, I work with Dean and his buddies on that. It's in a very limited capacity, but I do work on it. But I'm not getting paid or anything. So, even though I kind of on the inside of that project looking out, I'm just, I got manage expectations. Let's wait until the game comes out. Like, it looks good. I like what I see so far. But I don't think after what happened with KSP2 that I can ever be nice about an uncompleted product. And I chose those words very carefully. A better way to explain it would be, I'm sick of games releasing into 1.0 and then coming to the conclusion after playing the game for a certain amount of time, like, oh, this game has a lot of potential. Bull crap. Every game has potential. You released it and it has potential. That's not what a release means. I don't think that word means what you think it means. I'm sick of games being released with good potential, but nothing, because that usually means that they don't follow up. You know, so even though I kind of work in limited capacity on KSA, and I know the developers and I'm good friends with the developers, and they, trust me, Dean wouldn't want this any other way. I'm pretty damn sure. That's why we see eye to eye on things. This game needs the skepticism. It needs it. I don't think Dean would release an uncompleted product, and I think he knows what's at stake here. You know what I mean? I'm pretty sure that him and his boys that are working on it understand it. Especially since some of the people over there are ex-KSP devs. Ex-KSP1 devs. I think they understand what's going on. But, dude, even a game that's close to my heart like KSA or even KSP, after what happened with KSP2, I'm never being, I am going to be not harsh, but fair in my reviews. Because up until then, dude, I played a bunch of uncompleted games on stream. You know, played a bunch. You know, everybody like 5 years ago, it's early access. Everybody does early access. You know, but that just eventually morphed into an excuse for people to release uncompleted slop. Right? And that's not okay. Because not every game is going to have a No Man's Sky style recovery. No Man's Sky, that game sucked when it came out, but they fixed it. And they fixed it damn well, and it's a really good game now. I haven't played it much, but it is pretty damn good. But yeah, I'd say be cautiously optimistic, right? Or just manage your expectations. Even though it's a game that we love, I don't want to let my love for the game blind my judgment, which is basically what happened with KSP. And I'm ashamed to say that, but it is what it be. All right, I'm just trying to get this done. We're running out of time before Space News. Related, please advise them to avoid the word release in all of their communication about early access. They know, dude. But yeah, I'll convey the message. All right. Do I have all the parts? I have the forward struts there. Engine plate is in position. Auto strut grandparent, auto strut lock grandparent. There we go. All right. So this is the engine plate with Clydesdale in line. Try and hopefully reinforce the connection there. See what happens. Guys, my gut's telling me that this is the next thing that we're gonna try, but this is the next logical step to try, but I have a feeling it's gonna pop too. I have a feeling it'll blow up. That engine plate just makes things really weird. No Man's Sky's gotten a lot better, Pigeon. Hey, Alex, what's going on? And is there anything that you can use in place of the engine plate? Nah, not really, dude. Hope and pray. Yep. See what happens. Okay, headphone users, we'll start with a slow ramp. Thirty meganewtons and increasing. It broke off the hold downs. Full power. Breaking off the hold downs is not the worst. I see them. They're wiggling. Yeah, there we go. That broke it. What was the failure? Structural failure between Clydesdale and engine plate. Not surprised. Surprise dynamic test, pretty much, dude. I mean, we're asking a lot of 8 hold down points to hold down 75 meganewtons of thrust. I'll admit, that's asking a little much. So now what I'm going to do, this is just for testing. Now, guess what? Go into 6 times symmetry and strut to the engine plate. In fact, 2 times 6x symmetry. Because before, I couldn't do this. Because I couldn't run a strut from the plate all the way down to the fairing. Because we didn't want to run the struts too long. What Aqualex and I were talking about a little bit earlier. But now we can. So I can reinforce that connection with more struts. Let's see what this does now. Let's see what she does. Don't worry, she'll hold together. Hear me, baby, hold together. I don't know, man. I don't think the 12 struts are going to be enough to survive the bump load that we put on this thing, but we could do a mass simulator test in a second here. If this goes well, put the 2,000 tons on top of this thing and see what it does. About how many parts are we at these days with first stage since the redesign? So this is the engine plate with the Clydesdale behind it. It's not a lot, 150. Can they replace a payload bay COPV once the Starship is fully stacked? No. Well, May, when you mean fully stacked, do you mean like up on top of Super Heavy or just a fully built Starship? 170 parts. So it's 162 because we have 8 hold downs. Fully built. As long as you could access in there, maybe. You might have some trouble getting the COPV out of your letterbox door. You'd have to, i.e. you'd have to take apart. You'd have to destack the thing. All right, ready? So we broke off the hold downs again, but that's fine. Well, that wasn't really a good test because I hit the ground way too hard. Structural failure on the linkage between the S4512 and the engine plate. And then the link failure on the Clydesdale. Interesting. Interesting. Very nice. I thought I was a little higher up off the ground than I was. Test confirmed. Ground is hard. Noted. Yeah. Alright. Instead of a ramp, I'm going to push it to full power right off the bat. We'll see what happens. Is it a good idea to pause after clamp break off to see if the stage of the that stage of the mission is breaking something invalidating landing test? It's not, Erudite. It's not. I'm watching the action group over there, and I'm watching like over here. See how it says 8 launch clamps? If we send it, that should go to 7, and it should go to like 2, and it should go to 9. See? 2. Not good enough. Structural failure between the S4512 and the EP50 engine plate. Interesting. Interdasting. Let's see what that was. Let's see what that does. Maybe this is the trick. It's coming from inside the downcomer. Booster 7, probably. It was coming from inside the downcomer on that booster. Just saying. If you know, you know. If you look at booster 7. Cryo, 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 spin prime, spin prime, spin prime, static prime, spin prime, static prime, spin prime, cryo test. Yeah, Elmgar. What are you up to in the build process? Not much progress, just explosions. Which are fun, but... Okay, full shock load. Ready? Who thinks it's gonna explode? Hang on to your butts. It popped. Damn! Whoa. Freaking whirlybird tank. You see that? Structural failure between the Clydesdale and the EP50 engine plate. Again? Fozzie, hey, you're planning on going to Florida in September and going to KSC. Do you recommend doing 2 days and anything different then? You're going to Florida in September and you're going to KSC. Do you recommend doing the 2 days and anything different? Like doing 2 full days at KSC. Yeah. Yeah, do 2 full days. Do 2 days at KSC. That's good enough to really get the lay of the land, so to speak. To take your time and look at stuff. I don't know about you, but you know, like when I go through museums and stuff, I read every exhibit. That's like, think of it like if you're playing like a tower defense game, you know, you have to go through and you have to, or like if you're playing GTA, you have to collect every like trinket or whatever, like, or any, or pick your game. I don't know. That's what I do with the museum. I try to read every single exhibit. That's how I learn so much. So if you're gonna do that, if you're gonna if you're gonna do the museum the way I do museums, I would give it 2 days. 1 day at KSC is not enough. How many pads are you gonna blow up? As many as needed, Chris. These struts really didn't prove to be any effect, so. Well, actually, yes, they did. Oh, I'm stupid. Of course they did. You probably spend 90% of it in the Saturn V Center. There's a lot of good stuff to see, man. Cornelio, the family and I are going to be in Cape Cod at the end of the month. Any suggestions on what to do or what not to do while there? Cape Cod. Go to the National Seashore, dude. The National Seashore Wildlife Park, super cool. That's out on the very end of the peninsula. That's pretty sick. Pretty good time. Really nice drive. In terms of other stuff to do down the Cape, dude, I don't know. What are you looking to do? There's pretty much anything. Something with boats, maybe. Seafood. It's definitely on the list. Cool, man. You could go see Plymouth Rock if you want. That's basically by me. Plymouth Rock's kind of cool, I guess, if you like a rock that's in like a giant memorial. That Plymouth is pretty fun. It's a good time. There's a bunch of stuff to do there, like a bunch of good places to eat, good cool places to walk around. There's the Rock and the Mayflower too. That's pretty neat. Yeah. Oh, sister, I was forever changed by Plymouth Rock. It's a good thing, Andrew, you're saying it's a good thing KSP does not require repairs to test stands between tests. Andrew, there was a time where I played Kerbal by a set of rules where you did have to build all the test stands. And if you blew one up, oh, your pocketbook felt it badly. Yeah, my mission mode rules. That sucked. But the test stands were sick. Diabetic, you're from Plymouth. It's a rock. That's basically where I live, Diabetic. Yeah, Plymouth, man. But rocks are cool. It's cool to see it. But yeah, with this type of stuff, you could afford more rapid prototyping, you know? All right, I'm going to try something a little different. What I'm looking for right now is to you know, somebody suggested putting more engines, mounting more engines out on the fuel tanks. That might be a good idea. Mounting everything on the fuel tanks. Because what I really think is going on here is that inner 7 engines are pushing on the attachment point. Because think about it, dude. With the other points, you have the fuel tanks and you have 2 engines attached to each set of fuel tanks. That's pushing up on that point. But the center point on the engine plate has 7 engines pushing up on it and no fuel tanks. So I think we might be just stressing the engine plate joint. Uh... Give me 1 second. So this test, I only have one engine firing on the inner cluster, the center engine, and then the outer 12. Might not be enough to get us up off the ground, but we'll see. Now, what happens if we activate the other one? Huh. But see, we're not going to be able to do that. We're not going to be able to do that. That did work. It worked pretty well, actually. Oops. Oh, what failed? Structural linkage between the engine plate and nut. Interesting. I thought I was a little lower. It's hard to discern the height here because my control point's up at the top of the rocket, you know? You're originally from Buzzards Bay. Off the head of the bay, if you know where that is, down towards Wareham and Bourne. I know exactly where that is down there. Yeah. So, so like by where Mass Maritime is, dude. Yeah, I know. I was down there the other day, dude. We don't live far from each other, man. Yeah, we don't live far from each other, dude. Rocket review today? Yes. Used to deliver pizzas to Mass Maritime all the time. Worked at Pizza Boy in Wareham. Yeah, I know. All right, man. Right on, man. Yeah, I know where that is, dude. That's cool. Cool to see another local around. But then again, I ain't local to the South Shore, man. I'm from the city. But I moved down here because I like it down here. better than the city. All right, I'm gonna try to sequence this thing. Let's add the 6 engines in when we release the launch clamps. Let's try it. And we know that shock loading is going to break it. Yeah, I think I've weeded out the problem, guys. I think I got it. I think we're just putting too much stress on Kerbal's joints. So if I'm thinking about this right, somebody suggested taking the inner ring of 6 and putting them on the fuel tanks instead. And I have a feeling that that's going to work better. Okay, ready? Because if we try to fire 1, 2, 3, 4, 5, 6, and 7, it's just, that's too much thrust, that's too much pushing on the thrust structure. $50,000 pascals, 60. That's 10 psi dynamic pressure. That's pretty insane. That's a lot. That's what we call brute forcing, chat. Our thrust structure isn't good enough, dude. Xerax, if you're here, that's probably why yours was working, right? We're still going up, by the way. How's the testing going? We're taking steps, but baby steps, Isabel. Best way to fix things is taking small steps. Guys, I don't want to bring this back down. We're running out of time. I'm going to make the changes that I think we need to make. So first of all, I don't think the Clydesdale, as cool as that is, the Clydesdale center pipe, I don't think it's doing anything. So what we're going to do, I'm going to move the inner ring of 6 engines. I'm going to move those out to the fuel tanks. Okay? We're going to move those out. So my thrust structure in the center is just going to be one motor. Just going to be one engine. That's it. Is this thing an SSTO with most payload? Most first stages of rockets, Neptune, are for Delta V, not aerodynamics, but yeah.
Discovery.
Edmund, what's up, man? 25-month resub. Always nice to see some KSP. We're going back to Kerbal in a big way, dude. Don't worry, there's going to be more. This is only the beginning. I got you, Edmund. Right on. Is this based off Super Heavy engine count with Saturn V heritage? It's nothing like Super Heavy. It's like Super Heavy in the same way that, you know, SLS is like Super Heavy because they're both big rockets. This is an ultra heavy launch vehicle. It's actually beyond Super Heavy. It's what comes after. Think like ITS, like SpaceX's original ITS design. But this isn't supposed to be ITS. This is a post-Saturn Apollo class rocket. It was a real concept. Yeah, there you go, Neptune. It was a real concept in the 1960s. That's the guy right there. That's what we're trying to build.
Discovery. Go at throttle up.
Hey, Doom. Glad to see you're back in Kerbal. Do we know if Min misses ice cream? With this big of a rocket, we'll be able to sufficiently check. R6 was the Clydesdale. R5. .1. Save. Get rid of that. Get rid of that. Get rid of that. Take this. Attach it in 6 times radial symmetry. There you go. And then that leaves just our center engine. That center engine is on the fairing. Okay, rerun the struts. We're gonna have to run our struts a little bit different this time, though, because now we are not attached. These aren't attached to the fairing. So, what we'll do. Let's run sets here. And that means we need to rerun to the fairing like that. All right, in the name of time, let's just do that. Prometheus 5.1 stage test. Night Sun Temple. Get rid of the Mastercraft file stuff. You guys know the drill. When we christen a new booster designed for testing, we put the 4 batteries on. We put the 4 solar panels on, and then we get 8 hold down clamps Move the hold down clamps out here, like that. Set them to heaviest part. Put the hold down clamps in the different staging group. Save it. What if we had a Marvin for good luck? Add Marvin. I don't want to screw up the continuity of the test, but we'll put Marvin on there later. Okay, make sure our motor overclock is still there. Yep. All right, chat. Let's see what happens. How goes the ICBM? We haven't built much of an ICBM. We just built a bomb up until this point, 95. But I was thinking about the designs that you showed me, dude, and I was kind of thought of something, dude. In your design, so 95 built one of these guys while I was on vacation. So 95, in your design, dude, you were making the spike version with no engines in the center. My design has engines in the center. So you attached all your engines to the fuel tanks, right? In your design, if I looked at that correctly. Mine had the center thrust puck. I have a theory that I'm overloading the center stack of this thing. And that's why mine was failing so much. Now, with all that being said, what I just did, I have an outer ring of 12, an inner ring of 6, and a singular engine in the center, right? 4 of the clamps failed. That's weird. So, what I did was I took my inner ring of engines, which were on the center fairing, and put them out. They are attached to the fuel tanks now. So, if my theory is right, this should work. Hey Torch, what's up? Just wanted to let you know you passed your commercial pilot check ride today. It's been a long time since I've been a regular here, but my love for space was a prerequisite for what I accomplished today. And you were watching, you was a part of that. Yeah, all right, Torch. Hell yeah, man. That's kick-ass, dude. And I just figured out my rocket too. Everybody winning today, boy. All right. That's good, man. Hokey, 124 months? Jeez. Oh, Katra, thank you. That's awesome, Torch. Congratulations, man. Oh, yeah, we should probably land. Oh, Nelly. Come on, sum it down now. Oh, my God. I'm all right. Appreciate it, Chad, and thanks. That's awesome, man. Commercial check ride, bro. Look at you. That's pretty good, dude. That's not too shabby, my man. Here, hold up. Beer's on me tonight, buddy.
Oh, this is space. I'm in space.
Don't drink and fly. Don't do that. Yeah, no problem, man. Glad I could help. That's sick. Good job. Yeah, if you could just figure out how to convert Twitch subs into beer, then first of all, we could make a lot of money off that together. And second of all, please let me know. Or let me know and then do this. You know what I'm trying to say. Let me land this, okay? But did you see it? It worked. It worked. That was right. Now let's just try bonking it on the ground a couple of times and see what happens. Let's get the ground out to the road. Thanks, Brandon. YouTube chat says congratulations to Torch. I double stream on YouTube nowadays too. So the YouTube chat's going bananas for you over there as well. Mind the grass. Boop. You're ruining the grass. Not ruining the grass, it's fine. Look at it. It's fake anyway. Yeah, that did blow it up. All right. Now, was that a... I'll bet you, before we check, before we hit F3 and we figure out what's wrong, let's see. How good do we know the design? I'll bet you that's a structural failure between the engine plate and the S4512 tank. Ready? Boom. The fairing separated from the engine plate. Interesting. The S4512 was the second. Oh, see, we still have stuff to figure out. Still have stuff to figure out. But then again, this is the 5.1 design and not the 7 design. Frisbee! Oh! Explosive frisbee! Yeah. Yeah. Let's see what happens. No, my booster is not Ohio Sigma. No, it's Idaho Ligma. That's the new phrase, dog. You gonna lock out the fuel? Doesn't really make a difference. Mr. Sticker. Yeah, he's Canadian. It's a Canadian name. Is this a mass simulator test? That's correct. Come on! Oh no!
Discovery, go and throttle up.
It didn't hold it up. Ah! Thrust from 7 engines, 95. 7 engines at 3,000 kilonewtons of thrust each, so it's only 21 meganewtons on a fairing plate. Yeah, that's a problem. Yeah, that's a problem. That's a little bit of, that's a lot. Oh, here it comes. Oh, it's going to be a rut. We could get 8 of these to hold up the first stage. Surely 16 of these should be able to hold up all of it. That should be fine. It's just giving you strong spider rocket vibes. Nice. Want the vanilla? Do you want the cuttlefish and asparagus? Or the sticky dick in my balls? Is it possible with the second ring of engines on the tanks too? The mid ring and the outer ring are on the tanks, dude. You put 3 engines per tank on yours. 3 per tank are on mine. Stay up. Okay. Why does your rocket have the extra engine in the middle? If we ever decide to reuse it, it'll be easier to land on a singular engine in the center. Structural failure on the protective shell in the EP50 engine plate. Maybe we should just delete it from the design, dude. Hey, buddy, I think your rocket exploded. It's 5:03. Maybe we should just go with the original 18. I mean, I don't know. What, is it going to make a difference in thrust? So we'll end up making 72 meganewtons instead of 75. Oh, Wisp, you know me. All right, this is the last test. This is the last one. And then I'm gonna take a break. I'm gonna go grab some food. And then we space news. 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 Doo-doo caca poo poo. Pee pee. Yeah, I don't care. I'm not clicking on that 95. I'm just kidding, man. Are you okay? Nah. I'm just hyped. You know why? You know why I'm hyped? Because this is gonna work. Watch, ready? Maybe not. Oh, crap. How did the fairing fail? How is that? There's nothing attached to that thing down there. Hey, Aaron, what's up? Damn. Wait, is it still attached? It was still attached. Huh. That's all right. Why did I blow up my rocket on this test stand? Because he could buy another one. Frick yo stand, chat. Frick yo stand. Buy another one, you rich mother trucker. You know, I'm not just gonna blow a rocket up on his test stand just because. You know, I'm a little more mature than that. But yeah, I remember blowing up the test stand. Don't hate me. Darknesses. What are the 5 launch clamps say to the face? Slap! You got a bit of forward shell in your aft shell? Yeah, I saw that. Now, Darkness, the tables have turned. Do with them whatever you'd like. I mean, sometime today. Come on, well, we're young. Aha! 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 Look at what has happened! Look who's stuck outside in the drizzle! There it is, dudes. I had hold down clamps on the aft skirt still, 95. That was the problem. Oh, yeah. Oh, yeah. Now flip for lateral load tests? Alright. She's coming apart this team's captain! What failed? Oh, the tanks came apart. How many Grissoms do you think this could launch? Probably one. Probably put one into space fully fueled. Like, one moment. That actually survived a pretty good tumble before it blew up. But it looks like the fuel tanks moved around too much, but that's okay. Now land this on the moon. No, I don't think I will. I think I'm gonna go eat dinner. All right. Part 7, we made some good progress. So what I think I want to do with this, guys, is we're still going to have to attach something down here. I'm thinking having the Clydesdale in the design might still not be the worst idea. We might want to go back to the R7 booster and move the engines to the outside. And the reason why is the Clydesdale did reinforce this. And that'll make it so in the future, if we want to, I don't know. Not that we'll ever get to this point, dude, but in the future, if we ever tried to build a launch pad for this thing, we'd have something structural down the bottom that we could anchor on. That's my only real thing. Like, we should probably do that. But my first stage SSTO moon landing. Nice. Yeah, that's probably the way we should do this. Yeah, that's what I'm gonna do. Anyway. I just lost my train of thought. That's good. Yeah, we'd have to do a little bit more load testing with the Clydesdale design to make sure it doesn't overload the engine plate. But with the 12 struts in there, that's, yeah. What's our part count? We're at 190 parts on the first stage right now in that configuration, which is actually pretty good. Oh, no, it's less than that. Like 160 because the mass simulator up at the top. Let me get rid of that. 165. Okay, not bad. Cool. All right, guys. Well, that was fun. I got to make a phone call real quick, and then I'm going to go grab some food. So I will be back probably maybe in about a half hour from now. I know we went a little late because it's 5:15 now. Yeah, I need about 30 minutes. Got to make a call. I got a message. That message might be important. And then I'm going to grab something to eat. So don't worry, there's still plenty of stream left. On the YouTube, you guys know the drill. You're probably going to get about a 30-minute loss of signal. And then on the Twitch side of things, stay tuned. I'll keep the stream live. We'll listen to some nice background music. We'll put the chill music back on. And I will see you guys in a little bit. That's going to do it for part 7. Thank you very much for watching. And I will see you guys very soon. Stand by for loss of signal on the YouTube side as expected. Space news on the other side of the break. Later.